Sir, we'll start shortly. This is actually our lecture will be started fast. So we'll start the 10th technical session. This session will be chaired by Professor Bhubaneswar Das. It's my pleasure to introduce Professor Das. Professor Das is currently a senior advisor and research director at LM Intech Services Private Limited, Bhubaneswar, in the area of battery and supercapacitors. Professor Das completed her PhD in organometallics under the guidance of Professor Sarveshwar Guru from Utkal University in 1994. She worked as a senior scientist and subsequently as the principal scientist at Samsung Electronics, South Korea from 2003 to 2015. She was awarded as the best scientist twice at Samsung Electronics and nominated for the Chemistry and Engineering News Award for Best Innovation. She was a visiting scientist at Gachon University, South Korea from 2015 to 17, a research professor at Myongji University, South Korea 2018 to 20. She also worked the visiting faculty at Ravenshaw University in our institute OUTR Bhubaneswar from 2022 to 2023. She has won 30 granted international patents and 30 publications and has delivered many talks in SCS, MRS US and USA Organic Semiconductor Association Europe. Now I welcome Professor Bhubaneswar Das to chair this session.
Thank you.
Now we start the GB Behera Best PhD Thesis Award. To Dr. Rajat Kumar Sahu.
Good morning, everybody. So, before deliberation of the lecture, I would like to introduce Professor GB Behera, in whose name the award is constituted. Now, Professor GB Behera was born in 1939. He completed intermediate, one of the oldest college of the state, government oldest college, SKCG Pada. Then he completed graduation in the year 1958 and MSc from Ravenshaw College in 1960. He also did his PhD under the able guidance of Professor M.K. Raut, Mohendra Kumar Raut, the regional leader and great researcher of the state. Basically, we can say this is a pioneer researcher in the state of Orissa. Then he served in government colleges, 4 years in Puri College, 1960 to 1964. Then he switched over to Ravenshaw College for 5 years, 64 to 69. Then he joined as lecturer in Sambalpur University, Sambalpur. And now, immediately he became the professor of Sambalpur University in the year 1978. At that time, the youngest professor of the state. Now he is actually visionary leader and visionary head of the department, expanded like anything. At that time, Sambalpur University, that's staff position was 16, and because of the initiation and endeavor of Professor GB Behera, and then he started his research there, and more than 20 PhD students he has successfully guided, and many papers he has published. One, the first review, high impact review, chemical review, was published by Professor GB Behera, and second review, chemical review, was published by us, our group, Professor GB Behera and et al. So then actually it's very encouraging fellow, always inspire the youngsters to do research and for better teaching and whenever there. So then he actually went abroad, USA, Florida, University of Florida campus for his postdoc work, and he also got B.S.R. Gupta Award Best Teacher by OCS, and also Lifetime Achievement Award by Vigyan Academy, Orissa, and he is also social worker. And whenever he goes to any meeting for delivering speech, actually, he was preparing, seriously is preparing. Very good teacher, fundamentally is very sound. Understand? So a student need not see the books once the student listens to the lecture. Great teacher actually, versatile teacher. And also versatile researcher. Actually suggested to go that way, this way, and theoretical chemistry, actually develop theoretical chemistry, and they are also in Sambalpur University, surface science. And now he also social worker. He was the member of Western Orissa Development Council. Now this basically the award is constituted by his students, when a group of students of GB Behera, they have constituted this award, Bhubaneswar Behera Best Thesis Award. So with this introduction, I conclude, and I think this is a good honor to our Professor GB Behera by instituting the award. Thank you, madam.
Professor Behera, he will give presentation online.
Yes.
First of all, thank you to Professor Bhubaneswar for giving introduction about Professor GB Behera. I am really proud of to receive this distinguished award. First of all, I want to give to thank you to OCS committee members for giving me the opportunity to present my work in the ongoing social work. Next, I want to thank you to OCS for recognizing and giving immediately us prestigious award under the Professor GB Behera. Now I'm going to present my
Sounding बड़ा Yes, yes. Go ahead.
So, my name is Dr. Kumar Sahu, and I took 5 to 6 years to complete my PhD. So, to explain the whole thesis work in this limited continuing time to solve this area challenging work. So, I plan to discuss about 2 important chapters of my thesis in detail, and the rest of this chapter I will show in the summary. So, today my topic is molecular dimer, hydride and cation, synthesis and catalytic application with detailed mechanics inside. And these are the outline of my talk. First I will give the introduction about the advancement in catalytic reaction. How the catalytic reaction is progress over the years, starting from the use of the traditional metal reactors to the molecular division. Then I am going to discuss 3 important parts of my thesis, starting from how to design a ligand system or how to design a metal complex. Then use these metal complexes or catalytic in different challenges of organic transformation. Then how one can understand the detailed mechanistic reaction inside by isolating the key intermediate or by performing several arithmetic experiments. Next I will be discuss the summary of my slide. Then I will give the future concept. How one can use these complexes by solve the societal issues such as global warming. So first, advancement in catalytic reaction. Initially, people are using traditional metal reagents such as lithium aluminum chloride, lithium aluminum hydride, sodium chloride for the catalyst. But there are some drawbacks. That's why they injected ligated molecular complexes or molecular catalysts. Generally, they are using their high catalytic load. Generally, most of these are using the stoichiometric amount, but in case of molecular chemistry, only catalytic amount is used. Here, low reduction is happening, but here you can selectively use one compound and you can isolate the chemoselectivity as well as reduce selectivity. Your poor functional group tolerance, your high functional group tolerance. Here we cannot isolate an intermediate, but here we can isolate the key intermediate group, we can understand the reaction mechanism. So, scientists are interested in the ligated metal complex. There, they are using the complexes in the hydrochemicals, they are using for the hydrogenation reaction, but they face some challenges due to that they interested in the hydrogenation and hydrochylation. So, what is hydrogenation and hydrochylation there? The hydrogenation and hydrochylation reaction is the addition of pH or SiH bound to the unsaturated form. Similarly, the hydrogenation reaction is the addition of H2 to the unsaturated form. First, we are doing the hydrogenation reaction. Generally, that reaction are performed in the hot reaction condition using high temperature and high pressure. But as far as hydrogenation and hydrochylation is concerned, they are using at mild conditions. These are limited functional group tolerance, here there is a high functional group tolerance. As far as the case is concerned, that is the hazardous method and this is just a method. So first we have to how one can synthesize the ligated metal complex. So this story started with the synthesis of conjugated quantity ligand. For synthesis of metal complexes, the choice of ligand is very important. So I will focus on the synthesis of conjugated quantity ligand in this whole presentation. So first I want to give little bit introduction about the vanadium ligand. Vanadium ligand is essentially functionality where the central carbon atom is connected to one imino nitrogen and two arsenide. Comparison, but that synthesis and the metal complexes are well known in the literature. Comparison to vanadium, vanadium has good nitrogen in the center, and the ligand synthesis and metal are different to put in the literature. But as far as tetraaryl substituted conjugated with vanadium is also called as CPD ligand is concerned, there has been no before. For the first time, our group reported this tetraaryl substituted CPD starting from the diaryl carbonamide. When diaryl carbonamide reacts with ammonium chloride and 18 in ethanol, it is giving the quantitative conversion of CPD ligand. And this is analogous to the well-known NAC ligand. Most of the research group are using this NAC ligand. And after synthesizing the ligand, observe their highly different coordination modes. As far as weak metal is concerned, we have the two coordination mode, one is LS, where ligand behaving as a monoanic signature, and L2, where ligand behaving as a neutral ligand. It's not written as a conjugated, it is a bi-one mixed metal complex. After we synthesize the ligand and we observe their high coordination mode, then we choose the metal system. We choose zinc as a metal. Why? It is not biocompatible, eco-friendly, non-toxic equal. Where in your one hand is the ligand is there, other hand is the metal complex, metal is there, then we see important zinc-based metal complex. Then we prepare CPD stabilized zinc 1 diamond, where oxidation state of zinc is +1 and ligand behaving as a monoanic signature. After that, we synthesize electrolysis zinc 2 hydride, where ligand behaving is a monoanic signature, but oxidation state of zinc is +. Then we synthesize zinc 2 cationic complexes, where oxidation state of zinc is +2, but ligand behaving as a neutral ligand. After we synthesize these three complexes and characterized by NMR, experiments, mode-of-singly selective analysis, as shown here. After that, we visualize different organic transformations such as hydrogenation, hydrochylation, chemistry and dehydrogenation. After that, we did the detailed mechanistic study by isolating the key intermediate or active catalyst involved in the catalytic process, and moreover, we performed several stoichiometry experimental in situ studies for support the catalytic reaction. So first, how one can synthesize this zinc 1 process. We generally know magnesium and zinc are generally stable in +2 oxidation state. One question is, is it possible to isolate magnesium and zinc in +1 oxidation state or not? We know commercially available magnesium dichloride, zinc dichloride are available. When oxidation state of magnesium and zinc is +, one can think about what about Mg2 state. It is not stable. Why? Because immediately undergo disproportionation reaction to giving magnesium dichloride and elemental magnesium pure. Your magnesium oxidation state is possible. If one can set this small chlorine ligand into a bulky alien chelated ligand, then one can stabilize magnesium in +1 oxidation state. Keeping that in mind, for the first time in the literature, those group reported in 2007, when NACNAC stabilized magnesium iodide reduced in presence of potassium, it giving NACNAC stabilized magnesium 1 complex, where oxidation state of magnesium is +1. As far as zinc is concerned, for the first time, Carmona group reported in 2004 dichloroethylene compound where oxidation state of zinc is +1. But they did conduct initial declared zinc with commercial available diet zinc. They aim to synthesize hydroelectric zinc complex that is the typical zinc effect. But unexpectedly, they got a dichloroethylene compound where oxidation state of zinc is +1. But the main drawback of this molecule is that the molecule is highly thermally unstable. Once it comes to above 10 degrees Celsius, it started decomposing to the elemental zinc. So further chemistry from this molecule is really difficult. So how one can make thermally stable zinc 1 complex? As Carmona reported, I told this molecule, when this one we treated our CBG ligand, then deprotonation of ligand is happen and formation of hydroelectric zinc 1 complex. This molecule is thermally stable. Alternatively, this can be synthesized when this dichloroethylene reaction with 0.5 equivalent of ligated zinc hydride, then it also becomes the same molecule. And how to make this ligated zinc hydride that I will be discussing in future of my slide. Further, when this hydroelectric zinc 1 complex reaction with another equivalent of our ligand, it gives the homoelectric zinc 1 complex. Alternatively, this also can be synthesized when this dichloroethylene reaction with another 2 equivalent of ligand and giving the same compound. More importantly, these two compounds which particularly characterized are shown here the homoelectric zinc 1 complex and zinc bond distance is 2.40 angstrom, which is matches with the previous literature tag. After we synthesize the formally stable zinc 1 complexes, we utilize in catalysis. We utilize here for the dehydrocorrelation of terminal alkyne. When alkyne reaction with 1.05 HTP in presence of 2 more percent of one dimer, it gives the quantitative conversion of alkyne. A wide range of we did as shown here. Then we performed several stoichiometric experiments to establish the reaction mechanism. Initially, when the hydroelectric zinc bond dimer reaction with terminal alkyne where disproportional reaction is giving the zinc acetylide complex. It also can be synthesized when homoelectric zinc 1 complexes reaction with 2 equivalent of terminal alkyne by liberation of H2 gas. It is also giving the same compound. This is also structurally characterized as shown here where zinc bond separation is 3.04 angstrom. After that, if the zinc acetylide will react with 2 equivalent of HBP, giving the alkyl borate as well as zinc hydroxide with 45% conversion. When at the room temperature of 30 degrees, when we increase the temperature up to 70 degrees of there is no change in the conversion. So, to that reaction, we added another 2 equivalent of terminal alkyne at the room temperature of 30 degrees of the quantitative conversion of alkyl borate as well as zinc acetylide. So, based upon this, our stoichiometric experiment, we are able to propose the most probable catalytic application. Initial the hydroelectric zinc 1 complex with reaction with terminal alkyne by disproportional reaction and giving the zinc acetylide complex. Alternatively, when homoelectric zinc 1 complex reaction with terminal alkyne, it giving the same zinc acetylide complex. Further, it reaction with 1 equivalent of HCC via sigma bond metathesis, ZSC-DS sigma bond metathesis, giving the alkyl borate and zinc hydride in the equilibrium position. When this reaction is the reaction with another equivalent of terminal alkyne, it stops the equilibrium position and giving quantitative conversion of alkyl borate as well as regeneration zinc acetylide complex, which closes the catalytic cycle for the dehydrocorrelation of terminal alkyne. Here, hydroelectric and homoelectric zinc 1 complexes use as the catalyst and the active catalyst is the zinc acetylide complex. Next, we have to synthesize the molecular zinc hydride. But before that, in 1947, Orissa reported the parent zinc hydride. When they treated lithium aluminum hydride with the diethyl zinc, they synthesized the parent zinc hydride. But there are several limitations such as instable inorganic sulfide, thermally unstable, polymeric reactor, pyrophosphate. Overall, this molecule we cannot use for further chemistry. So that's why to overcome these challenges, scientists are interested in the molecular hydride. In this concept, Rusty group reported for the first time when NACNAC supported zinc chloride reaction with trihydroxylase in giving the NACNAC zinc hydride. reaction with dietizing disproportionation of ligand information of CBD supertensive ketine. Further, when it reaction with iodine via alkyl halide exchange in giving the CBD supertensive iodine. Then when it reaction with another hydride group, that is the potassium amidoborate via salt metathesis in giving the CBD supertensive ketine complex. And this is the stack enable from 3 CBD ligand to the ketine complex. And in case of the CBD, downfield characteristics appear due to the more acidic profile of the free ligand. So it is converted to zinc in the total function and a new effect as the upfield region due to the zinc ethyl peak. When it is converted into zinc iodide, this thing is totally essential. And finally, when it is converted into CBD supertensive hydride, a signature peak appears at 4.51 ppm due to the zinc hydride resonance. After we synthesize the zinc hydride, we utilize in the reduction of isocyanate. When isocyanate comes to our mind, it reminds us about the propane gas tragedy. So due to the methyl isocyanate gas, we lost thousands of lives. So how one can convert this toxic isocyanate into useful product? That I am going to discuss now. So as far as hydrogenation of isocyanate is concerned, in the literature in 2016, reported when structural butyl isocyanate reaction is equivalent of HBP giving the chemical product. After that, in 2017, we reported when isocyanate reaction is either equivalent or equivalent of HBP giving amino as well as N-bordil chemical product. But as far as partial reduction of isocyanate into N-bordil formamide is concerned, there have been no reports. For the first time, our group reported dehydrogenation is the catalyst for the partial reduction of isocyanate into N-bordil formamide. Moreover, when it reacts to equivalent of a chemical product, when it reacts to equivalent of it is giving N-bordil methylamine product. So here, dehydrogenation is used as a single catalyst for selective synthesis of N-bordil formamide, chemical and N-bordil methylamine product. Then we screen the substrate scope. When isocyanate reaction with one equivalent of HBP in presence of 2% catalyst room temperature change into 4 in the quantitative proportion of N-bordil formamide. A wide range of substrate with 3% represented, for example,
Dr. Sahu, you have 5 minutes to finish your lecture.
structurally characterized. So similar to one is reaction with 3% of HBP giving the N-bordil methylamine product, some represented examples shown here. So after we synthesize these 3 products, we want to know what are the sequential formation of these 3 products. For that, we perform a with isocyanate. Initially, we take the equivalent of HBP and time to record the NMR. Initially, we observe a characteristic appeared in the downfield region due to our N-bordil formamide products due to the N2. After increasing the temperature from 25 to 70 degrees Celsius, we started consuming a new capture at 5.2 ppm due to the amino acid. And after consuming a process, both of the total consuming a new capture at 3 ppm due to the N-bordil methylamine. So it suggests that preliminarily the formamide salt followed by the second product salt, after that both are inserted into the reactor with the formation of the N-bordil methylamine product. It giving the sequential formation of these 3 products in this view. After we know the sequential formation, we want to know what are the 2 intermediates involved in the catalytic reaction. For that, we perform several stoichiometry experiments. Initially, when dehydrogenation reaction with zinc isocyanate, we give the zinc formamide complex, which is structurally characterized as shown here. Further, when this one reaction is equivalent of HCP, it is giving the first desired product as well as zinc hydride catalyst. Further, when it reaction with equivalent of HCP, it is giving our second desired product as well as zinc hydride catalyst as room temperature up to 12 hours. When the same reaction is heated at 70 degrees for 2 days, it is giving the N-bordil methylamine as well as third desired product as well as zinc monoxide as well as another intermediate, which is also structurally characterized as shown here. So based upon the structural characteristics, intermediate stoichiometric experiment are in study, we are able to propose the most probable chemical cycle. Initially, zinc hydride reaction with isocyanate giving the zinc formamide complex, further reaction with HCP has our metathesis giving our first product as well as zinc hydride. Zinc hydride reaction with our N-bordil formamide giving the intermediate C. Intermediate C reaction with HCP giving the second product as well as zinc hydride catalyst. Zinc hydride catalyst reaction with the second product giving the N-bordil methylamine as well as intermediate I. Finally, intermediate IV reaction with HCP, giving of zinc will get a side product and regeneration of zinc hydride was observed, which produces the catalytic cycle for zinc hydride catalyst chemotherapy, hydrogenation of isocyanate. And this is all about my thesis work, and I first synthesize 3 different types of metal complexes and use initially one complex for the rate of reduction of alkyl alkyne, and I discussed then we synthesize petroleum into hydride, which as a catalyst for the hydrofunctional ketone to isolate several alcohols, then used for the selective reduction of isocyanate. Then it is used as a versatile catalyst for the CH, which addition to carbonamide to isolate several products. Then it is used as a catalyst for the dihydrogenation of isonitride to selective synthesis of 1,2-dimerilated amine product. It again is used as a catalyst for the partial reduction of nitride to selective synthesis of phencylamine. It is used also as a efficient catalyst for the de-aromatization of N-heteroallyl to exclusively one synthesis of 1,2 radioselective products. Both the hydrogenation and hydrogenation gas will got exclusive 1,2 hydrogenation products. And the approach that will compare CPG hydride with NAC hydride for the dehydrogenation of terminal alkyne, and with also CPG hydride is both efficient and giving the selective product in comparison to NAC hydride. We also take on 2-5 experiments. And after that, we synthesize several cationic complexes with protochemical isolation. And all the cases, we are isolating all the key intermediate involved in the catalytic process and also several experiments. And these are some representative examples of intermediate what we isolate. So the output of my thesis is open an opportunity how one can synthesis a ligand and synthesis a metal complexes, use that metal complex in different challenges in organic transformation. Moreover, one can understand the detailed reaction mechanism involved in the catalytic reaction by isolating the intermediate or by computing several aspects. And this is the future prospect of my work. One can use this catalyst transferring global warming gases into useful products. If you see that chart, which represents how gradually increasing the temperature of the air due to the greenhouse gases. Generally, the CO2 concentration is high, but as well as essential also, which is hydrofluorocarbon is equally responsible for that because it has high global warming potential than CO2, nearly 1,000 times higher GWP than CO2. Generally, SFC are using air conditioner, refrigerator, and chiller. So, how we can convert this SFC into useful products? So based upon the literature and composition, when SFC reaction with terminal alkyne in presence of catalytic amount of zinc chloride, that zinc chloride also I synthesized using my doctoral study and in presence of catalytic phase in the fluoroalkyne and isovalent processes, which is used in the bacteriomolecular drug molecule. So this way compound is formed due to lack of time not going to cover. And this is all about my thesis work and future work. One can how convert this greenhouse gases into the useful product. So these are my list of publications. These are the titles of papers which go to my thesis up to 9, and these are of my titles of paper work equally contributed. And these are some of my other publications. I have published 21 papers total in my doctoral study. And for that, I want to thank you to my PhD supervisor, Dr. Sunnapalai Banerjee, who today I am here. He really supported a lot during my doctoral study. And I also thank you to all my faculty members, scientific and non-scientific staff from SCS Niger, all my lab mates, and I thank you to all my friends and family members, especially my parents, my brother and my wife, who really supported a lot. And I thank to Niger, DAE, PNI, ACRB for the financial and the research support. And lastly, I want to thank you to the hosts for this prestigious award. Thanks a lot to you for listening to my presentation.
Thank you, Dr. Sahu, for your very good work. And questions, please, to this young scientist.
Hello. My question, the query that you have chemoselectivity of this reagent, particularly as reducing agent. You have done with your aldehyde ketones. What is acid chloride or ester or other things you have explored or not?
Yes, I also did the ester, but that paper is not going to my center. That paper already published. It's done to answer, but that paper
what is done actually?
Sir, we did initial hydrolysis and hydrosilylation, then we isolate the organolytic part, then after hydrolysis we also isolated the alcohol in case of ether.
That's okay.
I can show you if you want to, then I can show you.
Fine.
Okay.
Dr. Rajat,
Yeah.
You can see the, this one, the zinc hydride catalyzed the step number 1. Yeah. The zinc hydride catalyzed hydrolysis of ether. That way you can keep on
yeah, Dr. Rajat, thank you for a very nice and systematic presentation and also very good work, qualitative work as well as quantitative work. As you know, currently India is facing commercialization of many catalysts. Till now, India is suffering of catalyst generation. Still, we are dependent upon other countries. So, in that context, what is your contribution? Have you ever think of any catalyst you are going to be is a benzyl production, and what is the stability? And next question is zinc hydride. Many hydride are suffering for stability issues. So after 10 cycle, as I learned from the literature, after 10 cycle the stability issue of hydrate is big issue. Therefore people are now opting the coating or some stabilizing agent to stabilize that kind of hydrate materials. So how you handle the zinc hydride particularly?
Yeah, this is a very good question. So actually the stability of the zinc hydride is not that much stable, but because when people are synthesizing the ligated zinc hydride, it undergoes clamping to become H2 gas elimination and some bubble-active zinc complex, ZNF. Because the choice of ligand is very important for synthesizing the molecular zinc hydride. That I did not discuss here, so it is very important the choice of ligand. And other one I want to discuss to synthesize the ligated zinc hydride, the choice of ligand is very important to stop the clamping liquid. And other question I want to give the answer. How one can synthesize a catalyst? So based upon the catalysis, we have like a design a catalyst. What type of catalysis are doing based upon that? We have to design a catalyst. And the catalyst design always there benefit because you can isolate the intermediates so we can understand the reaction mechanism. Then also we can develop the catalyst exercise. This is the very important. So the stability is very good. Our this is very stable compound, so we can utilize it.
Thank you.
Thank you, Dr. Sahu, for sharing your experience with us and the students. Thank you. Thank you very much.
Dr. Rajat Kumar Sahu is necessary present here to receive the award. Dr. Professor GB Behera Best PhD Thesis Award on his behalf. So I request to please come to the dais and receive the award. Madhusmita Sahu. Yes, Madhusmita Sahu, please come. And I request Madam Das to please felicitate Dr. Sahu, Madam Sahu. She will be given a certificate and cash prize of rupees 3,000. with this, all the award lectures, everybody has presented and we have delivered the certificates, cash prize, whatever is allocated. So, this is how Professor GB Behera.
Next lecture will be given by Professor Das from Department of Chemistry, Rautela. I am reading out his credentials. Professor Das is a professor in the Department of Chemistry and IT, Rautela. He completed MSc from Utkal University and MTech from IIT Bombay in Material Science and Engineering. Then he received his PhD in nanochemistry from the University of Saskatchewan. It has so many alphabets, difficult to pronounce. Canada, under the supervision of Professor Robert W. J. Scott. His research interest involves nanocatalysis, photocatalysis, gas sensing, and toxic ion removal. He has published more than 60 journal papers, and 5 book chapters of international repute, with citations over 2,200, H index 28, quite high, and I-10 index 41. He was a recipient of many prestigious awards such as Professor R.C. Tripathi Young Scientist Award for the best quality of research carried out in Orissa by Orissa Chemical Society, Canadian Catalysis Foundation Award, and many more. Welcome, Professor Das, and please.
Thank you, Madam, for my introduction. A very good morning to all of you. As Madam told, I am basically a material chemist. I did my MSc in organic chemistry, then I moved to material science, and then did PhD in nanochemistry, and then postdoc in chemical engineering as a heterogeneous catalyst guy. So I'm basically purely a material chemist guy. Today's talk, I will talk about this talk which is relevant to the conference, which is advancement in material chemistry. Can I get a laser like this?
Laser will not work.
Oh, okay. So slide change
You need a kind of pointer.
How will the slide change? No, because I will move around.
Professor Das, I'm sorry. I'm letting you know that you have 30 minutes.
Yes.
for the presentation.
Yeah, I will try to finish before that. Okay. So, just go to the back slide. Till I need a slider. So the title of my talk is Chemistry with Nanoparticle-Based Chemical Gas Sensor. So I'm basically working on gas sensor part for efficient detection of toxic gases with some development, recent development of flexible sensors. Because we are moving towards sensors which are flexible, that means you can use as a wristband, you can attach it somewhere, so that means it should be a flexible part. These are some of the morphological features of these nanoparticle-based nanocomposites, you can say, and these are the sensors, and this is one which is a flexible sensor. That means if you bend it, its sensing property doesn't change. So that's the overall idea. So what I'm going to do in the next 25 minutes, I'll talk about my what we have been achieved over the last 5-6 years in this area. This is my group. I am basically working on nanoparticles as an advanced material for energy and environmental application. Basically, I work on EWE parameter, like energy, water, and environment. In energy, we do energy conversion, storage, and water splitting to generate hydrogen. And then in the environment, we do all these wastewater treatment. And then in the environmental remediations, I basically do heterogeneous catalysis, and then photocatalysis and gas sensing applications. So today's part, these are some of my recent paper, from a group paper. You can see we are working on different areas. I'm going to talk about the sensing part, which in the last 4-5-6 years, whatever achievement we have done, I will talk about few of these paper in today's talk. This is my group. Before I talk about my work, I should tell my group. Currently, I have 5 students. Vishal is who is a current student, he is a student of this institute. He's a very nice and bright student. I'm privileged to have him as my student. And then other students also are working. These are my past group members who are well placed in the reputed institute around the world. And these are the funding agencies which are supported during my work. Let's talk about my talk now. What I'm going to tell, what is a gas sensor, right? So from its name you can understand, if you have a toxic gas, you should sense it. Now how you can sense it? You should have some change in properties, right? So the change in properties can be measured in different way. And what we are measuring in the change in resistance. So if you have some gases, how the resistance is changing, we measure that, and that's why this is called chemi-resistive gas sensor. There are different types of sensor. One is electrochemical sensor also, other sensors are there, but we are focusing on this chemi-resistive gas sensor. So that means detection of gas to change the resistance by applying a constant voltage. So that is our target. And then your sensor has to be somewhere, right? And these are called substrate. So when the substrate becomes rigid, like this type of glass, IQ and alumina, this is rigid sensor. And then you have a flexible substrate, it becomes a flexible sensor. So our journey started, in fact, from the beginning when you set up your lab, you don't have everything. So our journey started with the rigid sensor, and currently in the last 3-4 years we are in the flexible sensor part. So I'll talk about this over the in the last 5-6 years what I have achieved or my group have achieved. This is a setup. You can see here, this is a gas flow. Whatever gas you are measuring, through mass flow controller you control, and then you have a chamber here. This is the substrate. This is the substrate where you put your sensor, and then you have a picometer which measures the current, and then you have a data acquisition system which collects the data and then you plot based on your measurement. So this is the real setup in my lab. We can see a picometer here, a screen here, MFC there, mass flow controller, and then you have cylinder, and then the chamber, which is very important, where you put your sensor and measure this. So this is a sensor fabrication. First you take indium tin oxide, and then you coat it, and then you put some copper tape just to make it have a electrical contact, and then you drop cast your material on the top of that, and then you put a silver paste to have further electric contact, and then connect that to your chamber inside the system. Okay, so now first is we are focusing on the oxide based structures. We all know the oxide structures are very important in the material chemistry area. It can be used for various applications. The question comes, why these oxide structures are very, very important? We all know these are because the moment you have a very small structure, your quantum phenomena is the dominant factor. Your classical phenomena is not the phenomena there which is applicable. So quantum phenomena is the effect, so that's called quantum confinement effect. So if you are free in this room, if I put light on that, your behavior will be different. Now if I confine you to a one tile, then your movement in the tile when light falls on that and your interaction with the light will be completely different. That's called quantum confinement effect. So how they behave, so that is why they behave in a different way. Then you have, the moment you have quantum confinement effect, their electronic and optical properties changes. Classic example is your board. When it's in the bulk form, we use it as jewelry form, right? The moment I reduce that in the form of gold salt with gold nanoparticle, it's a good properties as like catalytic properties, optical properties we get. So that is how the property changes. They have high surface area. Right? If you are working on water contamination, if you are working on sensor, your surface area should be high. So you should target that this material should have high surface area. So now you take a chewy gum. If you put it on the surface, its surface area is less. Now you stretch it, its exposed surface area is more. So the properties of the stretched one will be different than the one which is sitting on the surface. So after a few minutes you will find this is brittle and this is not brittle. So their properties will change. Their magnetic properties, all your hard drives are magnetic nanomaterials now. 100% of the hard drives which use the magnetic phenomena and they have enhanced mechanical properties. Right? Graphene oxide based materials, these are very, graphene oxide is one of oxide structure which is a very popular material. So all these properties make these oxide nanostructures a potential candidate in sensing. So what you need to do, can you further modify this oxide structure so that its properties further can be enhanced? And that is our group's target, which we use this to enhance. So how we can modify this? We have tested various approaches like oxide metal interaction, that means you have the oxide structure and then deposit that on a suitable support. So when you have a support, then you have different type of interaction. You can change the morphology, right? If you know nanomaterials, size and shape does matter. That's a very popular term here. So you change the size, you change the morphology, you change the shape, your properties will change. And then you use some synthetic method like template based method so that some porous structure can be generated which can further enhance this. So the overall objective is to play with this parameter and then see whether you can develop a potential sensor or not. So that's my group target. Let's talk about the first one. One is oxide metal interaction. So now what I do, I have this oxide structure now here, then I need a support, right? So that means this is support, I put the oxide structure on the top of that. Now how they behave, this interaction is very important. If you know a little bit about the physics part of this, lot of things like charge, transfer, spillover effect, all these important and there which plays an important role how this material will behave a potential sensor material. So now what you need a potential support material. In this direction, carbon based materials are very popular. And we all know graphene is the material of the current era because most of the applications are being done on graphene. The oxidized form of graphene is graphene oxide. And then in the last 5 years, if any material has shown greatest or important properties, that is energy, right? So we have tried to use graphene oxide in the initial days as a support material. Then we move to the energy for support material. Next is how you change the morphology. So you have to play with different like sphere, flex, rod, flower type of structure and modify its behavior and see whether this morphology can affect its overall sensing behavior. Third is use some soft template method, and in this regard MOF is a very important metal organic framework, right? So you derive your structures from the metal organic framework structure. Now how you derive? You can derive from different type of MOF. So it can be a metallic MOF, single MOF, like copper MOF, or it can be a bimetallic MOF. So you have copper, some other metal, and then you can make MOF, or you can make a coarser type of MOF. And then from there you derive your oxide structure. So that's very important. You can play with that and control it. So now the question comes, why you need MOF derived structure? Because definitely if you have definitely some advantage are there. So if you have a traditional method and then you have MOF derived method, in MOF derived method you have enhancement in properties such as you have higher surface area, more porosity, and then you can further functionalize these materials. So these advantages make these derived materials as a potential material. So what I am going to do now, I will just talk about fundamental thing about some of these approaches. For example, the strategy one we used, that means we have taken GEO as a support and then put an oxide structure. For example, here we have put a spinel structure, copper ferrite, which is a very popular spinel structure. Then you can see the TM images. These are the graphene and graphene oxide. So you have a multiple layer, right? And your job is to separate these layers. That means exfoliation. More you separate, more enhancement in the properties you will get. So you can see layers of graphene oxide here, and then on the top of that you have nanoparticle having spherical size. Then if you know TM, this is HRTM, and then this is selected area electrodiffraction, just to tell whether this is polycrystalline or single crystalline. And then you go to the sensing part. First you see whether my material is conductive or not, right? So to make conductive, what we do, this graphene oxide, we intentionally convert that to a reduced graphene oxide. Why? Because this graphene oxide has some oxygen functional group, which inhibits its conducting properties. So if you reduce them, that means you remove this oxygen functional group, its conductivity will be further enhanced. So with that target, you reduce this graphene oxide and then see whether they have a good conductivity or not. You can see here IV plot, because one is very low now. whether it's 5 seconds, 10 seconds, 15 seconds. That means it should quickly sense these gases, and then it should sense further down. So this curve will go multiple cycles. As Madam asked, how you can improve the homogeneous catalyst, the best way will be to make a heterogeneous catalyst, and the reason is it can be reused for multiple cycles, right? Same thing here in this sensor, you have to do hundreds and thousands of cycles just to see whether the same sensitivity is maintained over the period of time or not. So that is one approach. Then further we modify that. In the structure we modify with some nanoparticle. Here we have modified this with palladium, and we see further enhancement in the activity. This is, we measure the hydrogen sensing activity. These are all things which you need to find out whether your palladium exists in 0 state or +2 state, right? And XPS is a very popular technique which can tell you that your structure exists in the particular oxidation state or not. And this is Raman just to see whether there is some electronic effect or not, because as actual oxide support interaction is very important. The interaction will be only happen when there is a electronic effect, and those electronic effect can be measured from the Raman spectroscopy. Now the next strategy we opted for, change the morphology. So we have modified the morphology, like we synthesize rod, flakes, spear, flower, all this, and then make a first we make these different type of structures. Then out of that we found which one is the best activity. Then took that structure and deposited on the graphene oxide and make the composite out of that. So that assess how your gas is selective to that particular gas. These are the mechanism. Because of time constraint I cannot talk on that, but as I told in the second, third slide, surface area is important. So in the composite we found the higher surface area. So when I say surface area, is the BT surface area. You get higher surface area, which could be the one of the reasons for better activity. Then we went in the strategy 4. Now we move from traditional method to MOF derived oxide structures. So here what we have done, we synthesize the MOF, and then from the MOF we derive the oxide structure. So here we have synthesized different type of oxide structure like spinel structure, nickel, cobalt and manganese, and then from there we found which one is the better activity. This is another tool which is used in transmission electron microscopy. This is called EDS mapping, right? When you have multiple structures, whether they are evenly distributed or not, and in that particular ratio is maintained or not, that you can confirm from the EDS mapping. And this is highly required EDS mapping, which can tell us that how they are distributed. So then from the spinel structure formed or not, you can confirm that from the EDS. And then same thing, you do it, you measure the sensing activity, you do all these things, and you go for measuring. Now, here also, now we know in the previous strategy, out of different spinel, which one is the best spinel. So you choose that, and also different morphology you have tried, which one is the best morphology. Now you make the particular spinel with that particular morphology, and then see the potential outcome of that. So from morphology we found the flower is the best morphology. From the Spinel we found the zinc is the best. So now we make a zinc spinel with flower morphology and deposit that on the graphene oxide support and see how better is the activity. So you can see a nice flower structure here, and then you measure their sensitivity, and these are the oxygen vacancies as I told. So with different type of structures, the composite has the best generation of vacancies, which is the primary factor for the enhancement in activity. Now we made metallic MOF, now we move to the bimetallic MOF. I have shown that MOF has different type of MOF. One is copper MOF, then copper nickel MOF, then copper nickel core cell MOF. Every structure has its own benefits. We cannot talk because of the time constraint now. So now from the simple metallic we move to the bimetallic MOF, and then we derived the structures and then found whether this is a better sensor or not, and we found this is the better one compared to the monometallic MOF derived structures. So this is the oxygen vacancies. For example, here we get 38% in the composite structure, which is better activity. Now from the bimetallic, which is alloy structure, we move to the core cell structure. So now the question comes, why we need a core cell structure? Because if you know, in catalysis, core cell structures are better selective catalyst. Right? What do you want? Because some catalysts are very expensive. So to minimize the expense, you put the less expense as the core and make the cell as the most expensive one. It's like atomic layer thickness. 2 atomic layer, 3 atomic layer. So you are minimizing the price as well as making a very selective catalyst. The same strategy also used in other aspect, like here in sensing. You make core cell structures. So here you know we make a Scotty junction, which is very important in sensing. That means it's a heterojunction. And then the cell layer can be specifically designed to have high reactivity, whereas the core one will give the stability to it. So that means the core one will provide more stability, the cell one will provide the higher reactivity. So if you combine that, overall you get a better structure. So with that strategy, we made different type of core cell structure. Again, when you have core cell structures, their conformation is very important. In our work, we use copper oxide as the core and zinc oxide, nickel oxide, cobalt oxide as the cell. Then we checked which one will be the best cell out of this. So accordingly, we made different type of core cell structures. You can see here, this is the core. Now the moment you go to core cell, you can see nice rough surface on the core. And then you have to confirm that from the HRTM, this is the core and this is the cell type of structures. So from core cell structures, you can confirm whether you have a. So finally, out of different type of metal oxide, we found that cobalt oxide is the best cell structure with better activity as well as stability in this. Then again, you have to go different studies just to see whether the same core cell structure has been maintained or not, and then you do all the sensing measurement and to find which one is the best out of this. Here, you need to do the EPR, because I keep on telling you the oxygen vacancies. EPR is a very conclusive technique just to tell you that you have generation of more oxygen vacancies or not. And if you have higher intensity peak here, then you can tell that more oxygen vacancies have been created. So what we confirm from the XPS, that we confirm further with the EPR, just to tell that we have higher vacancies. Then obviously your sensor will work in different humid conditions. You have to see which one is the best. And then if you want to know why they are better, they should have better adhesive properties. Right? Because when you make a flexible sensor, the moment they bend, there is high chance your sensor will fall out. If you don't have a better adhesive properties, they will not bind to the substrate. So that is why you need to study their behavior, and then here this contact angle measurement is a very popular method. So if I summarize how you can design a potential sensor, we started with different type of oxide structures. We made the potential oxide structure. Then we found different support. We get the best support, suitable support. Then we change the different morphology, which one is the best morphology. And then we derive different type of MOF derived structure, which one is the MOF derived. So finally, we start from here. you get 5 chapter, you get a potential gas sensor. So this is how a PhD thesis can be designed. So here now I can show you, we found this different type of oxide structures, their sensitivity. Manganese spinel is the best we found, flower structure is the best morphology, RGO is the best support, and then we found the bimetallic MOF derived structure is the best, which can give rise to a potential hydrogen sensor. So this is how you can design a hydrogen sensor. Now by this time, we have some expertise to design some flexible, I will take maximum 5 minutes. Flexible substrate. So now the question comes, but if you see this, there is term is IDE based, right? So so far whatever I have shown you, this is a rigid sensor. Now if you have to commercialize it, you need something which is interdigitated electrode. Okay. So this is IDE. That means you need to mask something on your substrate, and then this difference in their space is very important. So in IDE, smaller gaps between the fingers enhance the electric field concentrations. So that means they will maximize the interaction with the gas molecule. So overall, you can find this shows better activity. Now different type of IDs are there, silver ID or gold ID. So for that, how we can make? Our method in the laboratory we make, first you make a flexible substrate, you are all synthesized in a laboratory, and then you mask it like different type of structures. Then you need to deposit gold or silver. This is called thermal evaporation technique, which is a very popular technique, where you deposit the silver or gold on the top of that. Now you make your composite, a particular spinel on the RGO support. Then there is a method called Doppler spread method. Through that you deposit that on your sensor material. Now this becomes your flexible substrate. Same thing you follow, like you make a different type of flexible sensor out of this. Now within that flexible substrate, we use this for a better ammonia sensing. Here we make different type of structures like cubes, sphere and octahedral test structures. Again you have to confirm that from different methodologies. The idea is to make a flexible substrate. So this is the gold mask ID substrate. These are all, and then on this you deposit your material, and then this is the real chamber. It looks like in your sensing chamber, and then this is the. So now you see ammonia up to ppb level. We are applying a patent for that. So this is ppb level concentration we can measure up to for ammonia sensor. And now as I told, this is a flexible, you can show it whether it's flexible or not. You can bend in different time, different angle, just to show that this is a better sensor or not. Again, the moment you bend it, the sensing activity should not change. Otherwise, you will not use it as a device. So we found that the third one, whatever sensitivity is there is slight change if you bend it 145 degree. So that means there is minimal change in their sensing behavior the moment you have a flexible sensor. Again, you have to find what are the region behind this activity, XPS, the surface area measurement, and then the ammonia TPD you do just to see whether they have good acidic properties or not, so that is ammonia gas is properly absorbing on its surface or not. By this time, we have expertise in synthesizing amexin as a support material. As I told, amexin is the in the current 5 years, if you see last 5 years, this is the potential material. They have excellent electrical conductivity, right? The moment you have something which is very good electrical conductor, then you need to overlook this material, right? So from RGO, you need to go to the amexin based material. Its synthesis is a little bit tricky, but we got success, and then we got multiple. You can see these layers of Duffin layer, actually these amexin layers in your system. Then what we did, we deposited in this amexin on the top of that some nanomaterials. Here we have used a peroxide based nanomaterial just to increase its properties and sensing activity. We did that. You can see here up to 1 ppm level we can measure for this perovskite based system. So now if you see for different gas, like I have already shown you hydrogen for NO2 gas, these are the strategies we followed. The overall idea is that you can get better sensor response with a T in and T out. That means how quickly it's responding, how quickly it is going down. So you should get this. This is the best. That means imaging support with a perovskite material is the best. Same thing we did with the flexible part here. We modify this and we see that also. Here there is no change at all, even if you bend it at 145 degree. So that's the good thing about this flexible sensor. Similarly, we have used these strategies for our methane. We find alkalized imaging, that means functionalized imaging with some alkaline system and a particular perovskite which shows better sensor response for ammonia, for methane gas. This is the work which the student who is a student from here, he did this. He recently published this bimetallic system which is from cheap and earth abundant metal, right? That's the need of the hour, because you want something which is very cheap and is easily available. So he made this and we just curiously wanted to know whether this can show better activity or not. In fact, we found that this is better activity compared to that. And then we use some synchrotron facility. Like a synchrotron, is a high beam radiations. All the fundamental physics experiment is being done in the synchrotron facility. So we did X-ups and Z-ups to understand what is the reason behind that. And we found interesting properties there. Because of time, we cannot say, but let me conclude my talk. The field of nanotechnology is going through a renaissance over the year. So one can tune the sensing properties of this oxide structure by changing its support, changing its morphology, changing its synthetic method. So that means rational design of such oxide-based sensor is possible. However, I cannot guarantee that this is better than some of the commercialized, but this is in fact is a very potential material. So that means more research. As I told, our current research is mostly focused on imaging. This is the need of the hour. We should focus on this. So that means there is a lot of interesting chemistry, physics and electrical engineering needs to be done. So it's a interdisciplinary research required. Thus a prominent role for chemists, physicists and engineers. So with this, I would like to thank the organizer for allowing me to deliver my talk here and giving you time to present whatever we are doing the last 6-7 years. Thank you all.
Thank you, Professor Das. Your talks are very intricate and awesome also, as I find. And actually, before requesting you to ask questions, I'll just ask very two simple questions. That is, what is the material you have used for your ADE? IDE, sorry.
Polymer, PET.
PET, simple PET?
Yeah.
Not anything else?
No, simple PET, and then we also tried the different like polymer. I have not shown the slide actually. This is PET.
Okay. But actually, I'm afraid while depositing the stuffs, it might rupture.
No, it's not rupturing, madam. You can see here I have shown you bending.
It ruptures and it cannot go for many cycles. And particularly your materials also, because you are using the Dr. blade method, so it's not uniform throughout. So
yeah, that we are modifying now.
Yes. So that's the thing that I was thinking of.
Yeah.
Right. And what is the thickness of your graphene layer?
It is 8 to 10 layer.
8 to 10 layers.
Yeah.
Okay. Great.
So
you are getting
6 to 7 nanometers.
So you are getting better result when you use graphene layer.
The single
instead of-
layer isolation is difficult. So
Yes,
minimum
I
5.
that is necessary, otherwise it will rupture. Yes, thank you so much. And if you have any question, I think you should ask question because this is an advanced area.
So, what is the temperature range in which this?
This is all room temperature. We are focused on.
I saw that all ambient conditions.
But and many occasions low temperature study is required.
Yeah, the good question, because if you increase the temperature, obviously the activity will be far better.
Yes.
We are not interested.
Low temperature.
We always want the ambient condition. So whatever activity we are getting, we are showing that. It may be, in most of the cases, better, but may not be better than some of the commercialized one. But our target is room temperature.
But experimentally one can
We have shown the temperature studies also.
Okay, one can go to say +5, not very difficult to
Low temperature because
absorptions severely gets dampened at low temperature, sensitivity severely gets dampened at low temperature.
yeah, but this low temperature is not practically, right? So if you go a mines area, you will not get a low
But
temperature.
in places like Russia and
Yeah, in Canada you can have
many countries, very
Yeah, it goes to low
sub-zero
temperature.
temperature is normal in many countries.
Sir, very nice talk. In this figure, the interdigitated electrode you employed is gold, right?
Gold and some cases silver. I am not shown that.
So without interdigitated and with interdigitated, what is the order of increase in conductance?
It's 5 to 6 times.
5 to 6 times or 5 to 6 order?
Of times in orders. That means if it is like 10% here, this will be 60 to 70% in 90. Sensitivity.
Thank you.
Definitely, that's why ID is. But thing is that you have to see the money factor also. ID is not that cheap compared to the rigid substrate. But again, you need activity better, so you have to go to the ID basis.
Exactly similar work I have done in 2015 on alumina substrate with platinum interdigitated electrode.
We don't have platinum facility here. We have gold and silver.
Oh, good.
So, thank you for your question and thank you again, Dr. Das. And because of our time problem, so can we interact later?
So I now request Madam Das to felicitate Professor Das.
Thank you, ma'am. The next session will be chaired by Professor
Akhil Kumar Sahu. Professor Akhil Kumar Sahu is currently a professor at University of Hyderabad. Professor Sahu received his PhD degree from National Chemical Laboratory, Pune, under the supervision of Professor Ganesh Pandey. He worked as a scientist and group leader in Sai Advancium Pharma Limited before joining University of Hyderabad. His research interest is the development of novel synthetic transformation for construction of new molecular entities. He has more than 70 research articles and 8 patents in his name. I request Professor Sahu to please chair the session, and the 2 talks will be delivered, one by Professor Molay Kumar Rana, Associate Professor, Department of Chemical Science, IJR Berhampur, and another is Professor Uma Prasanna Ojha, Professor, Department of Chemistry, IIT Bhubaneswar. Since we are half an hour late, I request please restrict to the time of half an hour.
Okay, so thank you, good morning to all of you. The first lecture is by Dr. Molay Rana from IISER Berhampur. So he did PhD from IIT Kanpur with Professor Amrendra Chandra, and currently he is a associate professor in IISER Berhampur. So
Good morning to all. First of all, I would like to thank the convener, the Orissa Chemical Society, to invite me to AMC 2024 conference. I would like to thank Professor Sahu for his kind introduction. So today I am going to talk about tuning the prototype mob materials to broaden their applications in combined experimental and computational approach. So I will give a brief introduction, and then I will talk on experimental and DFT study of transition metal doping in the zinc BDC mob to improve electrical and visible light absorption properties. Basically, this will focus on the band gap engineering of an insulator mob to make it a semiconductor and how it can be useful for visible light absorption based catalyst. The second one is uncovering the latent responsiveness of the water stable luminescent zinc BDC mob with a distinct morphology for advanced sensing of nitro explosives and ions. This is again focuses on the very fundamental mob, zinc BDC mob, which is known to be not so much water stable. How we have performed moderation to that prototype mob to enhance water stability, and how it can be useful for aqueous analyte sensing that we have studied there. The third one is post-synthetic modification of zinc BDC zirconium based metal organic frameworks with imidazole variable optical behavior and sensing. This again addresses the very fundamental property of a very well-known mob, that is UYO 66. It has zirconium metal and benzene dicarboxylic acid ligand. Its optical property or photophysical property is not that much remarkable, so that it is not useful for sensing and other electronic applications. Here we have shown that how this mob can be modified up to that level so that it can be useful for such applications. So we know that first of all, the porous materials are the materials which have pores, like cavity channels, interstices of various shapes, size, and they have a wide range of porosities, basically the weight to apparent volume ratio. The porous materials can be classified into two such major groups. One is based on the size. You know that the nanomaterial, they are so because the size varies from 0 to 100 nanometer. So they are classified like microporous, the size or pore dimension less than 2 nanometer. Mesoporous, the pore dimension it varies from 2 to 50 nanometer, that is mesoporous, and more than 50 nanometer, that is called the macroporous material. Based on building framework, also the materials can be characterized, particularly when the material is made with purely inorganic building units. So that is, for example, silica, that is a purely inorganic porous material, and then organic inorganic hybrid material, for example, metal organic framework, on which I will be talking on today, and purely organic polymers like covalent organic polymers. It is made with non-metallic elements. Metal organic frameworks, as I told, that it is made with metal ions and organic linkers coordinated to give porous network structure. The metal ions, it acts as the node. This node can be of single metal, or it can be a cluster of metals. And this cluster of metal or single metal ions, they can be coordinated to organic ligand to give various porous structure. It can be, so they can give 1D, 2D, 3D porous materials. Particularly, there are thousands of examples of such materials, and the metal and ligand that code the basic unit that is called the structural building unit, that is of 0 dimension. Now the effective synthesis, so there are a lot of synthesis techniques by which these mob materials can be synthesized. Among them, the sulfothermal method is mostly used by the researchers because it is more effective. It is means it works at a very low temperature. It is very cost effective, and it is so simple to control the morphology and crystalline phase of the materials. So that's why people have used solvothermal method. The MOM materials, as I told, that they are porous in nature and they can exhibit surface area as high as 9,500 meters square per gram. You can see it can be more than 10 football grounds. So that big surface area. So you can imagine how many molecules it can interact with 1 gram of sample. It can interact with lots of thousands of molecules, analyte molecules particularly. And the pore size it varies from 0.2 to roughly 4 nanometer. They are chemically stable, thermally stable. The framework, so that you can do any kind of tailoring operation on the framework. You can modify it to make it suitable for various applications like gas energy storage, separation, purification, drug delivery, waste disposal, catalysis, sensing. My previous speaker also focused on mentioned MOP-based nanoparticles for sensing application. Different MOPs and structural building units, as I told you, that ligand and metal, this unit, okay, that is called the this coordination unit, that is called the structural building unit. While it varies, it can give rise to different different topological MOPs. You can see their morphology actually different based on the structural building unit. Basically to illustrate it very nicely, let's say if you take the linker as the same, but if you take different metal ions, then you can get different types of morphologies very nicely. You can see it is quite prominent. Similarly, if the pore diameter is different, their morphology is different, everything is different. On the other hand, let's say if you take the metal ion same, but if you just vary the ligand, particularly if you lengthen the ligand gradually, then what you can see, the pore dimension it increases gradually, but the morphology remains same. Okay, this is called the isoreticular way of synthesizing MOP. So with this basic introduction, what our objective is that to study the very fundamental MOPs like MOP5, which is been widely used, UIO 66, which has been widely used, to perform some tailoring operation on those MOPs to make them suitable for sensing applications, to make them applicable for semiconducting application or visible light absorption application, even for catalysis application. If time permits, I can quickly touch upon that. So workflow, we have used experimental synthesis followed by various characterization, and in conjunction with that we have performed various computational studies, like we have studied the whole units in computationally using density functional theory method, or if it is very expensive, then we have considered a small unit, okay, that is called the cluster model, that has been subjected for the computational study to complement the experimental results. The first one, GBDC MOP, here, what we have done, we have synthesized MOP5. It is made on the zinc ion and the benzene dicarboxylic acid ligand, and then we have performed the metal doping. As I told you, that MOP5 is an insulator. Its band gap is around 3.8 electron volts. But with the metal doping, we try to engineer its band gap, and what we found out, so the structure is cubic. Metal dope variants, MOPs also, they pertain to the similar structure, and from the XRD data you can see that the peaks, they remain almost intact. Okay, so there is no change in crystallinity mass or morphology mass. So metal doping cannot alter the crystallinity of the material. And what we see that, So this is the UV absorption spectra. We can see this is for MOB 5. It gives absorption spectra 250 to 300 range. But when we perform the metal doping, this absorption spectra shifts towards right. That means dead shifting happens. So it shifts from UV range to visible range. And accordingly, we have calculated by using Kubelka-Mann method the band gap. What we found out that MOB 5, which has band gap of 3.8 electron volt, it is tuned, and the lowest band gap is found to be iron dope case. It is coming to be 2.63 electron volt, and it falls in the visible region. So for the absorption case, what we found out that the ligand to ligand charge transfer is responsible for light absorption because zinc is the retained system, so it cannot participate in the electronic transition. But the moment we dope the transition metal ions, so in addition to ligand charge transfer, there is ligand to metal charge transfer happens, and that is the region. Okay, this electronic transition falls in the visible range, and the band gap actually decreases. In addition to this, we have performed the computational study to understand what is happening. So what we found out when we computed the UV spectra computationally with the different percentage of metal doping, qualitatively we get the similar spectra, and we also get shifting of the spectra from UV to visible range. Okay, there is no change. Very interestingly, one can see that in case of MOB 5, the HOMO and LUMO, highest occupied molecular orbiter and lowest unoccupied molecular orbiter, they are located on the ligand, and that's why it gives ligand to ligand charge transfer. But when we perform the metal doping, you can see either HOMO or LUMO, they can be located on the metal side, and that's how it indicates the participation of metal in electronic transition. So this is the insight we get from the computational study, and when we measure the single photon counting experiment. So here we performed the lifetime measurement, and what we found out for the MOB 5 case, the lifetime is more compared to the doped versions. So what it indicates that due to electronic transitions, okay, LMCT, LLCT, the lifetime actually decreases for the doped variants. So these are the insights we obtained, and this indicates that okay, MOB 5 can be tuned from insulator to semiconductor. Now next study is again uncovering the latent responsiveness of the water stable luminescent zinc BDC MOB with distinct morphologies for advanced sensing of nitro explosives and ions. So again, this is this MOB 5. Okay, so here what we have done, we have synthesized MOB 5 in two different mediums. One is in organic medium, EMF, in another one is in a mixture of organic and water medium. What we see, there is a change in the crystalline morphology. Here we get the conventional this cubic MOB 5. But in this case, you can see we get the rod-like structure. Now, this rod-like structure surprisingly found to be aqueous stable, and this has been utilized for sensing of various aqueous analytes. Now, so the region you can see. So this is the same. These are the same images of this cubic MOB 5 or cubic zinc BDC MOB, and this is the rod-like zinc BDC MOB. And what we found out, their XRT patterns are different, their structures are different. Okay, this we all know. But in case of rod-like MOB, what we found out that water can coordinate to the metal side. So they come. So this you can see here that water are coordinating to the metal side, and that's how it. What it can do, it can actually block the other side and force the synthesis process to propagate in one direction, and that's why one can get the channel-like structure. We get a different polar XRT patterns. We did also DFT study, and from DFT study what we found out that in DMF medium, organic medium, DMF molecules can interact with only ligand. Whereas when we take water, water can coordinate with the metal ions. This is actually coming along with our experimental study. So interaction is more. And because of this water coordination, we get the rod-like mob. And water gets coordinated in the middle side in a very stable manner. And that's why because of the previously present water in the middle side, the water stability it increases. No more water comes and interact to break down the framework structure. So that's how this rod-like mob is more stable than the cubic mob. Here, this also has been reflected. We can see here that this is the cubic mob. You can see the broken PXRD pattern. Okay, after 1 day of water exposure. But when we take rod-like mob in water from 1 day to 7 days, almost okay, the PXRD they remains intact. After 7 days, okay, the PXRD changes slightly, but it is fairly stable up to 7 days. Similarly, this rod-like mob is fairly stable in a highly basic and acidic medium also after analytic exposure. So this is very interesting that the zinc BDC very means lot of literature so far up to now you can see zinc BDC mob, particularly mob has been widely studied. Nobody has focused on this rod-like zinc BDC mob. So this is the second time we actually found this rod-like morphology and performed some detailed study. Here we have done some sensing study. We have used the rod-like mob to sense aqueous, cationic and anionic cations and anions basically, and we have used also for different organic molecules or solvent, but we can see that it can very selectively sense iron and copper if we give in the mixture of all ions. Okay, so the selectivity is very high. By fluorescence, actually, it senses by fluorescence turn off. You can see the fluorescence actually quenches. Here we have used also nitroaromatic compound, for example, nitrobenzene. But we see that it selectively senses nitrobenzene. Now we know that nitro compounds are explosive compounds. We know TNP is used in RDX, etc., etc. So their sensing is very important. All the nitro compounds are highly sensed or selectively sensed by this rod-like this zinc BDC mob. So we found out the LOD, limit of detection value, from the Stern-Palmer plot that is very low. It is coming to be in the range of 0.6 to or 3 micromolar range. Especially for the nitroaromatic compounds, the LOD value is very low, 0.6. So we have also studied that what is the mechanism of the sensing. What we found out basically the inner filter effect plays a role for the quenching, fluorescence quenching of related to the sensing of these analytes. This is because the excitation spectra basically overlaps partially with the absorption spectra of the analytes. So that's how it gives rise to the inner filter effect. And we have also studied the recyclability. So up to 3 cycles we have studied and we found the retention of the sensing activity. Okay, so this material is fairly recyclable. So that's how this has improved. Means this zinc BDC mob. Okay, we found it is highly water stable and can be useful for aqueous analyte sensing. Now coming to the another one, this UiO66. UiO66, it is made with zirconium metal ion and benzene dicarboxylic acid. UI66 means whoever has worked on mob field, they know It is a highly stable mob. But the important thing is that this mob, the photophysical property is not that much interesting. So our focus is how to modify the photophysical property. So what we have done, we have performed the amine functionalization, and then through C-base reaction we have grafted this one, this carboxylaldehyde to carboxylaldehyde imidazole moiety. And because of this grafting, we can see there is no change of the pH certificate, so crystallinity remains intact. But because of this grafting, actually the fluorescence behavior changes. Fluorescence is enhanced in this case, and this enhanced fluorescence or its photophysical property is used for sensing different metal ions, organic solvents, and also some anionic analytes. But we found out that it can sense iron and copper. It can sense acetone by fluorescence turn-off, and interestingly, it can sense carbonate by fluorescence enhancement. So this dual optical behavior we found, fluorescence enhancement and fluorescence turn-off, by simply grafting this function group to the UIO66 framework. And when we studied the recyclability, we found out to fifth cycle this is fairly stable. We have not gone beyond that. It can be stable for more cycles also. But we have then looked into the mechanism of sensing. But we found out for the carbonate sensing, the fluorescence enhancement occurs. This is because of this proton abstraction. The reason I don't know, but what we found out due to this proton abstraction, which is captured in the NMR data. NMR data clearly shows that this proton abstraction is taking place. From our DFT study, we also found that actually carbonate takes away the nitrogen, the hydrogen from the mob material. Okay, so this leads to the enhancement in fluorescence. On the other hand, for the turn-off, fluorescence turn-off by other analytes like cationic, anionic, whatever analytes, this arises due to the inner filter effect. The region is just like the previous system. Okay, and here we also see the decrease of the band gap of the material due to functionalization. Next, the catalytic activity. Here, what we have adopted the same strategy. That means we have taken this UIO66 mob and we have drafted suitable function group to the moiety. Here you can see that we have drafted this moiety. The UIO66, it has 6 zirconium and oxygen that makes the structural building unit. This building unit is basically catalytically inactive. When we graft this functional group and to this functional group, actually when we coordinate the transition metal that acts as an active site for a catalytic reaction. So just I will skip these things, but I want to see. What I want to tell you that we can basically use this functionalized mob for selectively synthesizing amine and imine. And this imine selective synthesis of imine and amine is basically a difficult job, because imine, that one gets reduced immediately to amine. So amine is the final product. But with controlled environment and using this functionalized mob material, we can selectively synthesize imine and imine, and with high yields. So you can see that the percentage of yield. So we have tested various things. We have tested with various solvents. We have done some computational study to understand how the catalysis takes place, and what we found out that the results are actually synchronized with the experimental study for different metal substitutions or doping. Here you can say we have used this transition metals here. Those are responsible for the catalysis. And very interestingly, our computational study for catalytic activity. For example, the best catalytic efficiency is found to be with zinc metal ion doping. Okay, so this is found in the experiment as well as in our computational study. So these are the various reaction profiles. I will skip all these things, and finally I will conclude that okay, we have engineered the band gap of more material to bring down to the visible range. Now this can be useful for visible light absorption based catalysis. We have improved the water stability of zinc BDC MOF. Now this MOF can be useful for sensing of aqueous analytes or any other applications in aqueous phase. We have modified the UIO66 to enhance its photophysical property, which can be applicable for electronic applications, as well as by suitable modification of UIO66, this can be used as a super catalyst for selecting amine and imine preparation. With this, I would finish my talk, and thank you for your attention.
Thank you, Dr. Malay, for your nice presentation. Quick 2 questions is okay? Anybody has any?
Okay. Can I?
MOFs have been known since quite a long time, maybe over 25 years. They are fairly good looking, very good looking stuff. Thank you. They're fairly good looking, but they're pretty much expensive also. So to use them as sensors for cobalt, iron, nickel, where there will be very low cost sensors are available, may not be a fair proposition, right? That is one point, but maybe for other applications where we take some guest molecules more detrimental to health, like carcinogenic compounds or something, they can have some better applicability with a higher pore size and more specific organic and toxic molecules. That is just a brief suggestion, otherwise it's bad.
No, I totally agree with you, and this is the real challenge for technological adoption of MOF. But at the research level, I would say that dealing with the zinc and other metal ion sites I showed here, they are relatively of low cost. I would tell that in the sensing field, the rare element-based sensors being used because they are luminescent. Especially in the MOF case, finding a MOF without the rare is limited in number. Okay, this is one of the examples that the MOF material has been made a sensor using low cost elements without using rare. But technological adoption is still a challenge.
So thank you so much.
Thank you.
Now I request Professor Sao to felicitate Professor Rana.
Appreciation of from OCS. Okay, the next speaker is Professor Uma Prasanna Oja from IIT Bhubaneswar. So he did MSc from Ravenshaw College and followed by PhD from IIT Bombay in 2006. And after that he has moved to University of Massachusetts. He as a postdoctoral fellow. He spent almost 4 years, and currently he is working as a professor in IIT Bhubaneswar. So, floor is yours. Thank you.
Thank you, Professor Sabu, for the nice introduction. I think at the outset, I should thank Orissa Chemical Society and Professor Das for inviting me to this forum and allowing me to speak some of our recent work. And also, I think this is a very good occasion where I should thank all my teachers who have inculcated this essence of chemistry in me that has eventually taken me so far. So thank you, sir and madam. So here I start. The topic of my today's topic on which I am going to speak is covalent adaptable polymers. And these polymers are considered as one of a viable option to replace these one-time use plastics. So just a slide for the students that I put, that those who are considering masters and PhD program as a career option can consider IIT Bhubaneswar as a nice serene campus at the foothills of Borneo. And in chemistry, currently there are 14 faculty members in areas of organic, inorganic as well as physical. And we have a robust research environment. The teachers are prolific and publishing in well-known journals. And there is a decent facility that is generally used for state-of-the-art research. So please consider this as one of the options. And if any of you have any questions, I am around, you can always call me. So now coming to the topic, plastics have come a long way. In almost all spheres of our life, we see plastics. Let's talk about electronic industry, let's talk about energy industry, and in packaging, also in automobile industries, if we move on to coating, and also in implants, biomedical implants in healthcare and so on. This is just to name a few. Essentially this list goes on and on. If we just look at a small statistics, we can see that currently plastic is a $624 billion industry, and which is projected to reach around 867 by 2031. We cannot do without plastic, to just simply put forward. But then there is a concern that currently this lot of sentiment is echoing on stopping this one-time use plastics because of this accumulation of the waste that is eroding our environment, and of course it is contributing to the health hazards, especially the aquatic species, and also the environmental degradation. Just some of the statistics that have put in that we are pumping around 23 million tons of plastics in a yearly manner to the aquatic ecosystem. That is alarming, isn't it? And then if we can see that we are, the greenhouse gas emissions is currently accounted from the plastic is around 850 million tons. So considering all these, and then the latest is the microplastic. The microplastic is now found in bloods and in various organs of human. So considering all these, there is a dire need now to replace these with plastics that can be recycled and degraded. So for a while it was thought that maybe these biodegradable plastics will do the job, but then it was understood that they are not really like the natural systems. In natural systems degrade fairly in all kind of systems. You talk about soil, you talk about landfill, in fresh water, and then you can also degrade them purposefully using anaerobic or industrial composting methods. But then the synthetic analogs, they are not able to do the job. You can only degrade them under certain fixed industrial systems. And then not only that, they contribute to the creation of the microplastics, because the way they degrade is not ideal. And formation of microplastics is even more harmful than having a waste accumulated on the surface. So considering this, then the sentiments now have echoed. Can we replace that with something that will more effectively handle the concern? So from there, this concept of these covalent adaptable polymers, are, especially the networks, have come into picture now. Where if you have a look at the simple criteria, thermosets, because of their effective networking system, they exhibit adequate mechanical behavior. Their tensile properties good. They exhibit low hysteresis, and they are good for a number of applications because of their mechanical as well as thermal behaviors. But then they accumulate to, once their application is over, we are not able to degrade them or we are not able to process them. So they accumulate and come as a waste on the surface, and which is the concern nowadays. If we, on the other hand, if we look at the thermoplastics can be recycled, can be reprocessed, but because of their linear structure, they are not able to exhibit those, the kind of mechanical property that is exhibited by the thermosets. So these two have their own advantages as well as disadvantages. So these covalent adaptable systems, they bring the best thing from both these systems. So covalent adaptable networks, being covalently cross-linked, exhibit the mechanical properties of a thermoset, whereas the linkages that cross-link these covalent adaptable systems are dynamic in nature. That is the reason they can also be processed under thermal conditions. So they can be processed like thermoplastics and they can be used as thermosets. So from there this concept has been coined, and not only that, apart from displaying this mechanical as well as recyclability and reprocessing behavior, they also exhibit various smart responsive behaviors such as safe memory materials, self-healing behaviors, actuators, and also they can be used for various biomedical implants. So these properties are nowadays really important to fabricate the next generation materials, safe memory ability and safe behavior and so on. So considering that, so these efforts have now moved to develop different covalent adaptable networks, and these have many areas of application. If we look at, we can use it in sutures, we can use it in implants, they can also be used for scratch resistance coatings, and they can be used for flexible electronics, flexible batteries, and so on, and also in contact. In these areas, they find the application. So there is a purpose why we do research in this area. They also gel well with many of our recent national initiatives. I have put in a few, but then they go well hand in hand with several of the national initiatives put recently. Okay, so now just to show, mostly I have framed my talk based on the applications, based on the visualizations. So just to show some of the literature, how these materials are useful. So these couple of things shows that they can be a very good effective system to sequestrate carbon dioxide. Carbon dioxide is a concern nowadays. There are a lot of discussions going on how to utilize that, how to capture that, how to convert that. So you can see in one of these cases, this carbon dioxide can be used to develop the feedstocks for this covalent adaptable network. The first one that I have shown in is based on a thiamycal adduct system. Thiamycal adducts have some inherent dynamic characteristics, and then we can utilize carbon dioxide to develop these materials. Those are recyclable in nature. You can use that and then you can reprocess that. Similarly, in the second case, this is again another nice example which can be seen that carbon dioxide can be used to enhance or to elaborate the cluster size of these ionic liquid systems. And when we enhance or we expand the cluster size, the reprocessability increases. So this is also one of the idea that these covalent adaptable networks can be used to capture and sequestrate the carbon dioxide. The next example is of a scratch resistant coatings. Nowadays we are having coatings, but once the scratch happens, we are not able to do anything with that. So just imagine we are having a scratch, and then the coating is self-healing in nature. So when the scratch happens, we allow the condition for the self-healing, and as you can see, the scratch automatically heals after. And this is just a microscopic view. It shows how the scratch gradually heals and becomes normal.
So these are very useful for our automobiles and for even our cell phone covers as a scratch resistant coatings. And the third one is that these systems are also become very good starting material for the 3D and 4D printing applications. As you can see here, the last one shows that some of the 3D printing materials, those are developed based on these covalent adaptable networks. Not only we can develop these 3D printing and 4D printing systems, we can also mold them. So that offers another advantage, that a scratch happens, we can mold them. We need to add few other components to that, we can simply attach them. So all these responsive and important behavior adds to the quality of the application of these kind of systems. So carboxylate is one of the functional linkages that is considered as fairly thermally and stable, and also it has adequate chemical resistance. But it has been shown in recent literature that neighboring group can be utilized, or age-old organic chemistry, all of us know that, can be used to enhance the dynamic characteristic by pulling down the activation energy of this transistorification. In the first one, we can see here that if we are having a beta amino group, we can make it dynamic under around 150 to 200 degrees centigrade. Similarly, in the second case, it's a kind of we can see it's a thallic kind of system in the ortho carboxylate group. The ortho carboxylic acid group can also make the ester group to be dynamic under moderate temperature conditions. The third one is an oxygen-based system. This also shows that these ester groups can be made dynamic if we tailor the chemical environment of all these systems. So we also did some research in this area by utilizing the carbonyl group as one of the neighboring groups. So here we took 3 model systems. In this case, we simply took the malonate, and then in the second case, we skewed it by using a sterically hindered group. We just put a methyl at alpha position, and then in another case, we took the ester carbonyl group. So what we did, that this is a simply energy optimized structure which shows their alignment, because alignment is important for effective neighboring group participation. We can see that in this case, this is effectively planar, but when we put a sterically hindered group, then the planarity is somewhat getting compromised, and in the third case, it is again a planar. So we were anticipating that the first and third will be effective, and just to visualize what is the activation energy in all these 3 systems. So typically, NMR is a very effective technique to accurately understand the extent of conversion. So we use NMR, we typically carry out under pseudo first order conditions. We take one as in a relatively higher amount just to make it a pseudo first order case, and then we observe the conversion using NMR. NMR is a quantitative tool, so we can safely use that, and then we plot the corresponding RNAs plot from the half-life and see what is their activation energy. And as we predicted, it can be seen that when we put a skewed group, the activation energy is around 158, so it is somewhat on the higher side. But then in the other case, ester is in between 110, but carbonyl is very effective, and it puts down the activation energy to 53. So this is what? This is related to the temperature of the activation. So we can say that at certain temperature, this particular linkage will become active or reversible. And not only the ester system, we also find that these adducts, Michael adducts such as AJA, Thia and Hydra-AJA, they can also be very active systems for developing these covalent adaptable systems. Just look at the activation temperatures. 100 degree in the Thias Michael adduct case is around 20 degree below room temperature, and in hydrazide case it is around 50 degrees. So what it says, that when we are having an activation temperature that is so low, that means at that temperature condition they are dynamic in nature. So when we say they are dynamic, that means they become responsive. When they are responsive, we are able to induce these self-healing and self-memory behaviors in the system. So how we induce? I will show you some examples to demonstrate that. So this is one of the network that we prepared subsequently using this as the key dynamic linkage. And let's have a look at these mechanical properties. It's around 38 megapascal, which is very similar to polyethylene. Polyethylene is one of the system which is not degradable under any condition. But if we are able to have the same mechanical property and having a system that is swiftly degradable, then there is nothing better than that. So again, we are able to show that this is a DMTA trace that shows that, okay, the activation temperature of the system can be made around 150 degrees centigrade, and then if we are able to manage that temperature, you see the system becomes self-healing in nature. We make a plot, and then we are able to see that they are able to heal if we are able to take that system close to the activation temperature. And then we are further we demonstrated that the original sample and the crack, and after the crack when it is healed, they are almost display close to quantitative healing in the terms of mechanical properties. And look at the hysteresis. The hysteresis is almost negligible. So which shows that they have adequate load bearing applications, which is necessary for various packaging applications and other areas where you need the material to have adequate load absorbing capacity. And the next case, we again use a ADC kind of system based on the carbonyl neighboring group, and then we develop the network and we demonstrated the properties. Here you see we have taken two different pieces and they are self-filled and under the nominal conditions, and the self-filled material is also able to withstand the load, just to demonstrate that the self-filling is effective. Not only that, we are able to show that these materials can be reprocessed n number of times. So that means once we use a material for certain application and we apply the activation temperature, we can again reheal or remold to another shape. We can use it from some other applications, which is not possible with the conventional thermosets. So this is the advantage with these CNs or covalent adaptable networks. And not only that, let's have a look at this. This shows the shape memory ability can be tailored or can be programmed in these cases. We have shown 3 DMA traces where it shows that typically for shape memory materials, we fix the shape for certain duration and then we see what is the shape recovery time. So here it shows that if we tailor the shape fixing time, then we can also control the shape recovery time. So what is the advantage of that? The advantage of that is that the shape memory ability in these systems is programmable. Though there are a number of materials that is available that exhibit shape memory property, but the shape memory materials to be, the shape memory behavior to be programmed is really difficult. So in that case, it is displayed. And from where it is arising, as you can show, so now it has 2 segments. One is relatively hydrophobic, the other is kind of hydroneutral. So you put it in a polar solvent, the polar OH groups, they tend to go to the surface. But then when you use it, use a non-polar solvent and then try to pull out the polar solvent from the system, what happens? The non-polar core goes to the surface and that's how the material gets shrink because of the relative layer displacement. And this is not difficult to understand also. From the prospect of XPS we can show, in fact, there is a layer migration that is going on. So this is shown from the O and C, relative peaks that is taken with the original sample, the sample swelled with ethanol and subsequently the sample deswelled with hexane. We can show that these element changes that is clearly reflecting that this kind of a migration is happening. And just to show that just see, so this is the same polymer. We have taken 2 leaves and one side is fixed for a different time, the other side is fixed for a different time. You can see first one is opening up, secondly then the second one will start. So this clearly shows that the shape memory can be programmed in these cases. So the first one has opened up, now the second one is gradually opening. So this is the advantage. And why we need the shape memory to be programmed? The shape memory is programmed to show that these can biomimic, like the flower blossoms. How the flower blossoms? First the outside opens up, then the inside petal open up. So we will show you an example for that also. In the second case, you see that different petals are opening at a different time. So like we are able to biomimic, we are able to mimic the process of blossoming of a flower. So we can have a look at this.
ଶୀତ ଦିନରେ ଗୋଟେ ସେପ୍ ଖରା ଦିନରେ ଗୋଟେ ସେପ୍
So the two petals, these have almost opened, now the inside ones will open. So this is how we are able to show how we can develop materials that mimic the nature. It's a very important area of research, and we can categorize that this is the next generation of materials on which research is currently concentrated. So now we have developed another class of materials using carbohydrates. Simply they are biocompatible as well as biodegradable, and there we have shown their application that currently we are having solar panels on the rooftops, but then consider the environment, especially for Orissa, where the temperature is somewhat higher, and in fact the sun ray is actually stronger. So in that case what happens? We waste lot of solar energy. So in that case we have shown that with this class of materials, if we coat that with on the bottom of the solar panel, what we can do, we can conserve energy. So there are phase change materials incorporated into these systems, and then what do? They improve the efficiency of light. Just have a look at the LED that is glowing with a coated panel. So it is glowing with more intensity compared to that of the black material because of the overheating. So this can be overheating, can be protected with these systems. This is very important from the perspective of the application of energy consumption. So we have also developed a number of materials in this area in recent times. We have developed isocyanate free foams. Lot of polyurethane foams are in market, but they are carcinogenic in nature. We have developed foams that doesn't include any isocyanate in that. Then we have developed shape shifting materials, shape morphing materials. The materials, those are able to change their shape automatically. We have also developed some of those materials. We have developed some actuators. Then we have developed some materials, those are recyclable, as well as we have developed materials, those can be used as ECG sensors and also as self-healing plastics. Now I will show the last example of another class of materials that you have prepared by conjugating a hydrogel with this CAN. So what we have done, we have taken this typical CAN and then we have conjugated that with a hydrogel. And what is the advantage of that? Is that when we do a gelation of a hydrogel under UV light, we can control the direction of the growth of the network. Or in other words, we say we can control the anisotropicity of the network of this hydrogel. So in this case, as can be seen, that if we are able to grow the network from the top surface or from the side surface, we are able to change the anisotropy. That is the reason we are able to control their actuation behavior, and the resulting sample are able to show multimodal actuation behavior, mimicking these naturally pine tree kind of systems. We can also develop soft actuators. We have done some science to prove that also. So in this case, these are the mapping, elemental mapping done on HPS as well as done on SEM. So this SEM is a EDAX mapping, whereas this is a elemental mapping. We can show that depending on the medium, where it is hydrogen, where it is water or it is ethanol, in water system, the hydrogel segment tend to be on the surface. Look at these pink lines that represent the hydrogel systems. They move to the surface, but when we put it in the organic solvent, the pink come to the center. So clearly, these hydrogel and organogels, they are able to change their segmental positions, responding to the environment. If it is in a hydrophilic system, the hydrophilic segment go to the surface. If it is a hydrophobic system, the hydrophobic segments go to the surface, and that is what acts as a carrier for their soft actuation behavior. And this is very important in a number of applications. Nowadays there are a lot of research that is going on soft actuators. And similar results we also observed from the EDAX mapping. We can clearly show that depending on the medium, this elemental acquisition is becoming different, the distribution is becoming different, and as a result of that, you can see we can able to generate a lot of different structures that is coming out as a result of their actuation behavior. We can fabricate a number of different shapes. These are the simulated shapes, and you can see the real generated shapes are very similar to what is the simulated shape. And this is not only this. We can also go beyond this. This is just state of the just for sake of some examples, and we have shown it. But this number can increase further. We can use the partitioning. We can integrate photolithography and several other things to integrate to the basic design, and we can develop a lot of different materials that exhibits different shape and different way of actuation. And again, I will show you that these actuators can in fact work in the medium. So this is one of the actuators. It can be seen that it displays the load bearing ability. So now this robot will pick this and drop it in here. It's automatic. We are not doing anything to that. The actuator is opening off, it will fold, it will lift, and it will pull it back in this, and it will be able to deliver to the job. So these work as micro robots for micro environments to perform the duties. These can be utilized. So this has now taken the load, and now we are changing the medium. Is able to do the job. So these are some of the material. We are looking at real life application. So when we do research, we keep an eye on where we are going to use this. So that is a main essence of our research. And in another case, we are able to see that these materials are able to fly like a fish. So these are the organic materials, but they are able to behave in a lively manner. So they have become alive. So we have just shown a couple of examples considering the time constraints. I know Akhil sir is there, so he is hitting me, just get out of the place. And then this is the acknowledgements to my PhD students whose work has in fact contributed to this. And so these have graduated and doing their postdocs recently, and these are under progress, and the funding agencies. And we are very thankful to all different funding agencies who have supported over the years, and then to our collaborators. Now it is getting the data. It's really a challenging aspect. So especially RRCAT and our theoretical simulation partner at NIT Durgapur and other places. So I thank all of them, and with that also I thank all of you with this small conclusion. The conclusion is that the CANs, they hold promise to be biomimicking in nature, also to be responsive, to be sustainable, or to summarize in all, they can be intelligent as materials for further applications. The key is to use bio-based resources so that the whole system becomes biocompatible and biodegradable. And then the application areas which we are considering currently is all these three, especially the 2 and 3 that we are putting our efforts currently. And then we are also doing some work to integrate AI and ML to see if the materials can be developed with a predictable behavior. So this is a very important and a future application. We have started some work and hopefully next time I will be able to show something on that. Thank you all. Thank you for your patience. Thank you, sir.
Thank you. Very exciting information, Professor Mohammed and Prasanna. So the floor is open for few questions. First is Madam.
Okay.
Thank you for a nice presentation. I just wanted to know, is this polymer is thermally stable at what temperature?
These are beyond 200. Up to 200 there is no issue. We have PGA data, I have not shown in this, but they are safe up to 200. And the kind of applications that we are considering is alright for 200.
Okay. I have a question. In the initial of some of your slides, after your trans-esterification reaction, in the active methylene carbon, you have put 1-methyl.
Yes.
Okay, and you showed that the property changes, angle changes, and all that. Is it due to the planarity change, or it is due to inboard effect? I am asking from organic point of view, because in place of 1-methyl, if you put 2 methyls, the cone angle changes.
Correct, sir.
So that that is called inboard effect, Christopher inboard effect. So that the Baldwin rules, as per Baldwin rules, the two ester groups become very close. Cone angle changes. So cyclization becomes better.
Better.
So what I am suggesting, in place of 1-methyl, you put 2 methyls, and let us see the change.
Okay.
If there is substantial change, then only that Baldwin rule and inboard effect both occurs.
Can be taken care of.
So that you do with a substrate.
Sure, sir. Thank you, sir. It's a very good suggestion.
It's great solution.
I know, sir.
Instead of also, in addition to this, if 2-methyl group, you put a cyclohexyl or cyclopentyl group, you have a conformational bias. And that conformational bias may make the, this trans-esterification, whatever you are doing, will have a much more effect. Okay, anybody else? Okay, so there is no more question. So thank you. You are working in such a great area. So I'm thinking, I'm sure the future will be proud of you. So thank you so much. Thank you.
Now I request Dr. Sahu to felicitate Professor Oja. Since we are half an hour late, there is no tea break. Tea will be served here. This is the last talk of this event. We started with great scholar who has delivered the first talk, that is Professor Mahendra Rao Memorial Talk by number 3. And we also end with an excellent talk and a renowned physical chemist by inviting Professor Ashok Kumar Mishra. He is a Professor Emeritus, Department of Chemistry, IIT Madras. And I request Professor Ajay Kumar Patnaik to chair this session. Professor Ajay Kumar Patnaik completed his PhD in 2000 from Uttar University He joined Orissa Education Service as a lecturer in chemistry in 1984 at DAV College, Koraput. He served different institutions such as the DAV College, Koraput, Bhadra College, Bhadra, Kalikot College, Barampur, Utkal University, Revenja College and Revenja University. He has 35 years of teaching experience at the UG and PG levels. He has published 65 research papers in national and international journals. His research fields are chemical dynamics and drug-metal interaction. He is a life member of number of prestigious societies such as Indian Science Congress, Indian Academic Science, Ultrasonic Society of India, Odisha Vigyan Academy, Science Congress, Odisha Vigyan Prachar Society, and also former president of Odisha Chemical Society. Now I request Professor Patnaik sir to please chair this session. So before we start, since there is a time for preparation, I request if any deliberation we can do after this, because a lot of Olichem awardees, those are the very school students, they have already reached. So our program must complete in time so that they can go for lunch. From the school they directly came here.
Good afternoon to everybody. Professor Ashok Mishra requires no introduction, but still it is my duty to read out his biodata. Professor Ashok Kumar Mishra completed his BSc from DAV College, Bangalore 1978, MSc from the University of Delhi 1980, received a PhD from IIT Kanpur 1985. Then he served as a lecturer in chemistry in Sambalpur University from 85 to 92. Then he went to the Gunma University, Japan as a fellow and joined IIT Madras in 1992. Then again he visited the Japan, then 2002, stayed there 2002 to 2003. Currently he is working as a professor emeritus in the Department of Chemistry, IIT Madras. Professor Mishra is a recipient of CRISI Bronze Medal from Chemical Research Society of India, Fellow of National Academy of Science. He has also received Acharya P.C. Rai Memorial Award from Indian Chemical Society and Professor W.U. Malik Memorial Award from the Council of Chemists. Professor Mishra works in general area of physical chemistry, photochemistry, fluorescence spectroscopy, and 32 students got PhD under his guidance. Now 4 students are working. He has published 235 research papers in national and international journals. Now I request to start his talk.
Thank you, Professor. Hello. Can the last person hear me? My sincere thanks to Odisha Chemical Society for giving me this opportunity. I know that. Is it better? Their program was tightly packed. I wanted to come, but thing is, unless I give some talk or something, I won't get a leave from there. So I requested to somehow accommodate me, and I sincere thanks for that. This conference is on materials. My basic area is photophysics and fluorescence spectroscopy. So I work on fluorescence spectroscopy more than work with fluorescence spectroscopy. So what I did then was to try to collect the material that I got somewhere which relates to materials. And that's what I will be presenting. Didn't get time at all to condense and compress the slides. Large number of slides, please don't bother about them. I'll just tell a little bit from this slide because really I didn't get time to make a better preparation for this talk. So this is my research group, and these are the research areas that we talk about. Actually, this pointer doesn't work on this page. So the one way of doing that is probably from here. Just 1 second. So maybe this is much better. So as you can see, we do work on fundamental photophysics and analytical photophysics. That's an area which I'm not covering today. We work on materials and many other things. So this becomes a part of the research that I'll be presenting. And we do work on a variety of instrumentation related to fluorescence spectroscopy. So what I will do is, being a teacher, first few slides are always explaining what is fluorescence. As you would have seen, and I'm really impressed and happy that even on the last day of the talk, the audience size is so big. Wonderful. And in fact, let me add to that. The quality of presentations in this conference, this OCS conference especially, it has been much better. I've not attended all the conferences really, but what I'm seeing is the quality of presentations are good, the quality of participation is good, and I see a lot of reception from the audience for the kind of talks that were coming up here. It's really a heartening kind of a feeling that I get for future progress of all the OCS related conferences and so on. So with that, so this is what you can see here is, let us say a molecule here. I deliberately made this in a blue color because there is a red shift of fluorescence there. There is a red than fluorescence. So this molecule which is dark, as it gets a photon under certain conditions, it gets excited, goes to the excited state there, but you see the time taken for that light matter interaction is only 2 seconds. And after reaching the excited state, it can stay there, unless it stays there a little longer, there is no fluorescence, long frequency. But if it stays there for longer, somewhere around 50 seconds or nanosecond or even longer, time stay in the excited state, what happens is it's not comfortable in its orbit environment, so it adjusts itself. So that is the energy minimization. That leads to some kind of stabilization of the molecule in the excited state. Not a problem. So I think I have to optimize it. So what I do is this. So what I do is I will present from here. So I was talking about this state, which is stabilized in the excited state during those nanosecond time scale, and from here there is a possibility of fluorescence in a nanosecond time scale. There can be many other activities that can happen from this point. But what I am looking at is this fluorescence. The cycle is back. The cycle is back. This molecule will receive another photon. I can go back and so on. So this is this basic fluorescence spectroscopy in a nutshell. There is a name put to it. It's called the Jablonski diagram. I have simplified it. What you see here is why the control that I have, which can use to extract information using fluorescence spectroscopy. The controls are this. The photon that I am using, I can change the photon energy, wavelength of it, shorter wavelength, more is the photonic energy. I can change the intensity of the light, and there is another important property of this light. Normally people use unpolarized light, but polarization of light under certain conditions gives a lot more information. You start using polarized light initially and look at the polarization of the light that comes out. Correlation of that gives another set of information. All these three parameters, I'll be talking about it again. Three properties that fluorescence spectroscopy is used for. It can be steady state, that is continuously there can be a photon that is coming through, or it can be pulsed. So time dependent incident of photon, so that there is a time dependent fluorescence photon that comes out. So together, then it becomes a truly multi-parametric system. I'll take a little more time here. It's a multi-parametric system. 3 independent parameters: intensity, energy, and polarization, anisotropy. They are continuous form and the time dependent form. Totally there are 6 parameters. Any spectroscopy, a multi-parametric spectroscopy, is a powerful spectroscopy technique. For example, if you take NMR, just shift is not going to give you much information. Shift as well as all the splittings that you see together gives you that information because it's multi-parametric and so on. So this is a good system. So the kind of systems where we use fluorescence just for fun. One set was of the variety of soft matters. We have already seen a lot of talks. The last talk was absolutely excellent. So a lot of soft matter related areas as well as hard matter also. So we have worked on them, and we also worked on some luminescent material. So these two I will be briefly talking about in whatever time we got. So in this soft matter, often a lot of this soft matter will be, so for example, gel-like systems or membranes, etc., etc. These structures are created through a certain level of hydrophilic hydrophobic balance. And if you can use the suitable fluorescent probes, which can probe a particular domain in this balance, in this local heterogeneities that are there in the system under various conditions, you get information about the structure of it, the dynamics of it, the performance. So that is how it is. So the soft matter already is there here. I did not tell you what the forms are, even if you already know about them. So different structures form under different conditions. Micelles, inverted micelles, membranes, tagged arrangements, and all that. And you'll also see that in many of the soft matter there can be an anisotropic structure that is forming, where fluorescence can be fairly useful. What I said initially is that as a photon is incident, the molecule goes to the system, whatever the fluorescent molecule goes to the excited state. It stays there for a few nanosecond time. And what happens during this nanosecond time is, it goes through a lot of physical, chemical or physical interactions. So, the interactions that happen in the excited state, these kind of interactions and many others, that is a part of photophysics. This happens in this time scale only, around nanosecond time scale, femtosecond to nanosecond time scale. Okay? So, fluorescence spectroscopy and this photophysics are inseparable twins. That is how we use fluorescence spectroscopy. And each of these has its own corresponding theories, and if you understand these theories, we use these theories, these concepts, to understand what is happening in the excited state, interactions. At the same time, it is not that you are probing the properties only in the excited state. You can also probe the regular properties, even in a non-excited state systems, by using these excited state interactions. And why fluorescence is important? If you see, for the last, if you look at all the presentations that were there are a significantly large number of fluorescence applications you would have seen. But again, you would have seen that most of the applications were generally intensity based, and quite a few were, of course, the time-dependent decays and lifetimes were also used in some of the applications. There can be much more than that in any of the fluorescence spectroscopies. That is one. And one of the reasons why it is so important in biology now, without fluorescence there is no biology, molecular biology or whatever. There is hardly any biology that can happen without fluorescence. You know why? Because the sensitivity of this is right up to picomolar level for a fluorescent This kind of sensitivity is not there in many other systems which are so easily accessible and so easily usable. So these are all reasons for all the fluorescence related things. It's a good area to work on and so on. So there are various concepts which has been used to understand these interactions. One of them is excitation prototropism. What we found in my early days, in fact, even when I did not get enough funds from elsewhere, I started using, 1/2 as a fluorescent probe. It has a problem. The problem is that you have to excite it in the ultraviolet rays and emit also. It's not too strongly visible, the emission. Somewhere around 350 to 400 nanometers. So you have to use in ultraviolet range, but the advantage is that, on excitation, especially in a water-like medium, where this proton can go, on excitation the proton goes, it forms an anion, the anion fluorescence is around 455 or so, the original neutral form fluorescence is around 350, there is a 100 nanometer shift in this, so they are very cleanly separated from each other, these two, and this helps in just looking at the presence of moisture, water in any system that is available. We use that very significant, and the corresponding science goes in the excited interactions as converted to equations where you can find out numbers. All that happens. So what we did, all that, I will not be telling about it, but we initially started using it in liposomes. What happens is naphthol will be distributing there, but the naphthol which is sitting at the interface will have a little more anion formation because it is accessing water. The naphthol which goes to core will be still emitting from neutral form. Now, if you start changing the temperature, if there are phase transitions in this membrane system, it's very nicely captured at the phase transition. So as you can see, this is the neutral form fluorescence, this is anion-neutral form fluorescence, they're very different from each other. We use that somewhere to find out how the bile salt, interacts with the membrane, NADC and NAC. It was a prolonged work. I'll just tell you the summary. What happens is this, that NADC, that as you can see, it enters much more number of NADC, deoxycholate enters because of the hydrophobicity there. NAC penetrates less, and when they penetrate, these molecules do perturb the membrane, but the extent of perturbation of the membrane can be almost quantified by just looking at this ratio of an neutral form fluorescence intensity, and you can also get additional information because what happens is, so for example, the anionic form lifetime is roughly around 8 to 10 nanoseconds in water. It can become around 15 to 20 nanoseconds at the membrane interface because of lesser non-reactivities. You can quantify almost these parameters just by using various fluorescent parameters. So we did a lot of those studies. We also studied this gels, the chlorinic, how with temperature, how it changes and so on by changing environment, how it changes, they are organized and how it changes by using same 1/2. Excellent results. Only thing is you cannot image them because they are in the UV range. Various chlorinics that we used, and the structural changes in chlorinics, etc., etc. I'm not going into details. The gel network that forms and the corresponding, the strength of the network can also be sort of mapped to these two fluorescence parameters that I used here, the intensity as well as the fluorescence lifetime at various stages. Somewhere with whatever experience we had, we thought a molecule of this type, this molecule existed already, but then we sort of synthesized this. I'm not a synthetic chemist, I took help of a student, a postdoc who was a good organic chemist. So we got it, and we found that this particular molecule responds to all the 6 parameters of fluorescence that I talked about. All the 6 parameters very, very efficiently. So we use this molecule to show how it can sense polarity, how it can sense local viscosity in a variety of different systems, the soft metal systems that we use for the phase transition and so on. Again, the details are not necessary, I'm just telling a story here. The staining happens here, you can actually, this is in the visible range, so you can get different colors, same molecule. The solvatochromism is so high, so strong, depending on the local polarity, that there is a significant color change with local polarity, and it is able to stain a variety of cells. This was another one I have chosen. See, what happens is ultrasonography, when it develops, how do you train a doctor with, without taking a real patient for checking for ultrasonography? They use some models. They call it phantoms, tissue phantoms. And they use polyacrylamide gel for that. So what I had done was, we worked on polyacrylamide gel and its behavior earlier. So one of our electrical engineering colleague, what he said is that a particular doctor, it is right now, in Chennai, he is looking for a better phantom model, which will be more efficient. The conventional phantom models that he was buying to train students was not good enough. So polyacrylamide was one of them. We studied literature, and with my experience of this work, whatever I had done in fluorescence, what we had realized at that point of time, I'll tell you, is that where it is. I'll directly go to the results. See, if you take a lot of initiator, what happens is you start with a monomer, acrylamide monomer. If you use a lot of initiator, the gels that form, it nucleates somewhere, it grows, but the size is not much, because all the monomer gets consumed. Large is the initiator, the gels will be smaller, spherical, this type. Okay, so if you use more monomers, you get very large number of small such structures interconnected. If you take less monomer, it takes longer time. Initiator, take less initiator, it takes longer time, but they become hard gels. So now you can tune between the hardness of the gel and the softness of the gel by simply adjusting the monomer, the initiator concentration. So we did that regularly in a very periodic, very nicely, until we reached the human tissue and some of the cancer tissue strengths of the material that we made. So what we did was this one. So we tuned all that, and that's how it is. And there is something called ultrasound elastography. What it does is a regular ultrasound gives you an image, but let us say there is a tissue, there is a cancer tissue which is hard tissue, and there is a soft tissue on top of it. If you press it, these two types of tissues get pressed differently. It's called ultrasound elastography. So by just taking an ultrasound image, and ultrasound image under pressure gives you slightly different information. And that different information can be color coded, and it can be imaged and displayed as an image. So this is what was one of the second work that we did, work on it. We again tuned the property of these polymers, simple polymers basically, but more importantly, we looked at all these were sort of monitored through a fluorescent molecule only, mechanical properties also. And then we did that. Eventually, I'll come to the details of it later on. So what the different ultrasound viscosity parameters, the biological tissues, the phantom that we made, just to map it to biological parameters here, it took us 6 months of hard work with a PhD scholar, postdoc scholar. Okay, so the acoustic impedance, etc., all these parameters we mapped very nicely with a biological tissue sample, and then we worked on it. As you can see here, if you just get we use the same sample. Let us say if you get an image of ultrasound, it will be like this, but you get a little better image by just using elastography. That is, you compress it and get the data as you are compressing and decompressing. So these are the tissues that we worked on it, and the doctor was very happy later on using this material for training his students. If you color code that, you actually get a kind of resolution with the material that we got, which they were not getting in certain materials. This was a satisfying one, and so on. So this is one part of the soft matter system that I was trying to present. I could have done a better work by condensing it, but I could not get time. The other one was we were working on some fluorescent push-pull organic molecules, which can be used as light-emitting material and so on. So we did, again, I'll go through very quickly the kind of different molecules that we made, the color changes that were happening and so on. And some of them are so sensitive that they could sense different vapors, for example, this one is acetonitril vapor. The vapor comes in, the color changes, you dry the vapor, it goes back to the original color and so on. So vapor sensing material that we made, and since the color change was right over the UV visual range from 400 right up to 700 or so, it was possible to create white light much easily with certain compositions, so that as you can see here, you can put them together and you can actually create some sort of white light out of it. Different spectral behavior for different molecules. We studied a huge lot of these kind of molecules over some 3 or 4 PhD students. One of the interesting information and observation that we had once is that see, it's a single molecule. This single molecule emits twofold. Like it has its own local emission here, it has a charge transfer emission here, and under certain condition of concentration and local polarity, it also forms an aggregate. So you actually get all the three R, B, G together, which gives a single molecule white light emitter. Is the first example of that, and so on. So it goes like that. This particular molecule showed a chromism, what they call. That is, if you thermochromism, if you heat it, the color changes, and if you simply cool it, the color doesn't change. But you cool and sort of, it's an organic molecule anyway. So you can rub it a little, it goes back to the original color. So obviously there are some structural changes, crystal structure changes in these molecules, but we could not study that because getting single crystal out of this was not my cup of tea. This, the idea of using the LE emission and the ICT emission and the aggregate emission together was so interesting that we extended that further to create pure white light with a one molecule, single molecule. We did some more such experiments on that. With that, these cross-conjugated polyens were very nice. They work very well. Color changes you can see right from blue to deep red, dark red, so on. So these are some of the things that I picked up for this different organic molecules. Not much. So this is the last part that we're talking about. This was the interesting one. See, we had worked on another area of fluorescence all the time, that is for multiple fluorescence. So you take any water, you take any pond water, any water, it will be fluorescent because of the decayed matter. But that fluorescence you cannot attribute, you cannot really map that to any molecule. It's a complex fluorescence. So we did a lot of work on this complexity of fluorescence, complex multifluorophoric systems we called it. So there was a German water scientist who was following our work, and at one point of time they said, can we have a joint collaborative project, Indo-German project, basically to develop a fluorescence-based system for monitoring fecal matter in water. Fecal matter in water is a real problem in almost all countries, including developed countries. So, and especially in our country and many other underdeveloped countries, it is a bad one. So monitoring fecal matter, so the plan that he had was that for fecal matter monitoring, you can go to fecal pigment monitoring. Okay, stercobilin and urobilin. And for fecal pigment monitoring, stercobilin and urobilin by themselves are not fluorescent much. They are little bit of fluorescent. So can there be a system, a fluorimetric system where with that very weak stercobilin and urobilin fluorescence can be captured? That was our original proposal, journal proposal. As we went on doing research, we found that a 100 years old technique that was existing for measuring urobilin concentration in urine in a zinc complex, urobilin zinc complex was given here. So then we changed our research pattern altogether. We started using zinc and we created a full structure out of it over a 3-year project and all this, this is a real problem, fecal matter problem. The idea was this: fecal pathogen is something that is affecting us. If fecal matter is there, fecal pathogen is there. Only then they exist. And fecal pigment will always be there with fecal matter. Fluorescence is weak. Let us enhance it by complexes. And we did that. These are the different structures. Then a lot of photophysics, a lot of physical chemistry and many other things that I will not go to. The corresponding fluorescence of fecal pigments themselves, you need to understand that because they are aggregate forming. They are not very soluble, they are aggregate forming. And dynamics of this aggregation itself is very important to understand the concentration of it in the solution. So with all that, that is a long work. All using fluorescence and many other techniques. It is very difficult to get this fluorescence out because the scattering is so much that the fluorescence will be, half of the fluorescence will be buried under the light scattering. So it's difficult, but we did that. We did all that. We did some modeling to figure out how the aggregates form and so on. We also worked on the corresponding gene complexes. Anyway, there's no time. I will just quickly go through. So various possible stoichiometries, and we understood it in a much better way, bigger way than ever before. And if it is an ordinary water, no two water from any source will be ever similar. The hardness will be there, a lot of dissolved organic matter will be there, humic matter will be there. Think about the fluorescence. You cannot extract that fluorescence out easily. How to take out the fluorescence that is not required is not easy. So all those things we did. For example, you see the humic acid fluorescence, the humic matter fluorescence is extremely strong. The actual fecal matter fluorescence comes somewhere here, almost impossible to see. It's a 2-dimensional fluorescence. Excitation emission matrix fluorescence I have plotted. This fluorescence is what we want, but the interference from this fluorescence is very significant here. What we eventually managed to do with all our research is this: suppress the humic acid fluorescence, the native fluorescence, and enhance the fecal matter fluorescence, and almost delink themselves, each other, so that they don't interfere with each other. I personally was extremely happy that we could do it. I had lost hope almost. I got a brilliant student, Swam Prakash. You tell him and he knows what to do. And eventually, an instrument was designed. There was another company here, a German company there. They made a prototype, this prototype. I don't know when this will come to market, but using this, we have tested samples in our own lake, our IT Madras lake. Srinagar, one of the company that I was interacting with, they were consulting the Srinagar in Uttarakhand for water quality management, and then somewhere here I forget which place. So they tested this device at this point, this point, and this point, because they were consulting them. But this Swam Prakash is there. And this is, because we are collecting our own water, a security has to monitor us. And then the project got over, but we further, continued with it, got much better analytical methods out, and very rapid and sensitive detection that we got finally, because it was a zinc complexation. We found that we just put a zinc sulfate or I think zinc acetate it was, and just at a drop of water there, if there is fecal matter, the green color comes, fluorescent green color under a UV excitation. So this we patented in fact. Okay. This is, I don't know whether this may not work. That's the problem. It may not work, but you could have seen the bright fluorescent light that comes out. Okay, so this is so the 20 went on to find out when we did a study, essentially a computational study. We found that there are two possibilities of two cavities. One is here and one is here. Zinc is something that we use. Zinc was also going there. But since the cavity sizes were different, we thought we'll use a series of methods to see whether we can maximize this advantage to different types of cavities. So we did that, and that is how in fact the patent came. We found that a gadolinium zinc combination gives the
by trial and error method.
It was system-wise. First to understand where the interference is coming from, and then try to remove it. But it will be, give a problem and find a solution kind of. There is no generic solution for this.
Yeah, that's right. It is problem oriented.
It is very specific. Especially using process is used so much in body system. Most of the analysis, a lot of cellular studies that are done, fluorescence is strongly used. Everywhere this problem is there, everywhere people do find solutions.
Yes, you try to sort it out by usual means. Yes, that's very good, and maybe it's useful for quantitative purpose at times. And I think I would learn many more things from this lecture also. Thank you very much.
Any more question we can discuss because we are already 45 minutes.
Let us thank Professor Mr. by clapping your hands.
Now I request Professor Patnaik to felicitate Professor Miss. So thank you everybody. Thank you Dr. Mishra and thank you Dr. Patnaik. So all our technical session is over. Now we have to move to the last part of the occasion, that is valedictory function. Within 5 minutes, we will start the valedictory function.
A very warm afternoon to everyone present over here. So now we are going to start our valedictory function. Now I would like to invite all our distinguished dignitaries to please come over the dais. So I would like to invite our chief guest of this function, Mrs. Renupava Nayak ma'am, Registrar, Orissa University of Technology and Research. Ma'am, please come at the time. Next, I would like to invite the President, Orissa Chemical Society 2024, Professor GB Behera sir, to please come over the dais. I would also like to invite the President, Elect Orissa Chemical Society for 2025, Professor Smrutipava Das ma'am, to please come over the dais. I would also like to invite the Secretary, Orissa Chemical Society and Dean Academic Affairs, Professor Achyutananda Acharya sir, to please come over the dais. Next, I would like to invite the convener for the annual conference of OCS and AMC 2024, Professor Vigyan Ranjan Das sir to please come over the dais. At last, I would like to welcome the Joint Secretary for OCS 2024, Dr. Smriti Patnaik, to please come over the dais. Thank you all. Now, may I now request our student volunteers to present the bouquet to our esteemed guests. With this warm and fragrant gesture, we extend our heartfelt gratitude to our esteemed guests for gracing this occasion with their presence. May this token of respect and appreciation set the tone for a truly memorable day ahead. Thank you, everyone. With utmost respect, the Honorable President of OCS 2024, Professor Ajay Kumar Behera sir, presides over this meeting. Sir, your guidance undoubtedly added immense value to our deliberations. Thank you, sir. It's really a proud moment for all of us. In this 38th annual conference, the establishment of Institute of Chemistry took place. Congratulations to all, and especially to all the former presidents of OCS. In this joyous occasion, I request all the dignitaries to please join for the celebration of this memorable moment by cutting the cake.
Institute of Chemistry.
Institute of Chemistry birthday. तो birthday नहीं, भूमि पूजा. Institute of Chemistry.
This cake cutting celebration is done because this birthday of Institute of Chemistry.
अरे आपण माने ठीक है जानते
Let us give a loud round of applause.
शांति के सेठी ठिया हो शांति के प्लीज अरे आपण
Institute of Chemistry Journal nela.
प्रेसिडेंट माने खाइबे सेक्रेटरी
आसतु 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 रोहित आसुन विश्वजीत Sir, you are everything. Sir, मुझे संस्कार वाले बेड़ा ले तो बीच है जो मॉडल तुम्हारा उतरा वो पूरा इमोशनल वाली गई सर एमनी तो आपने बहुत ले अभी की सर स्टार्ट कर लिए लेकिन अच्छा है चालू आम सार बस पछाड़े सार कंडीशन कर
फोन कर दे आसो फोन कर मैडम पैसा पटे लिखिक समस्त
Thank you all the guests and all the teachers, former presidents. Next agenda is a presentation of awards. First we have to start with the Holy Chem awards. Other awards will follow later on. for Holy Came Awards. First is Pratipta Kumar Baliyarchi, DAV School, Public School, Chandrasekhar. I request our chief guest to give the award, and with a cash prize of rupees 3,000.
The second prize goes to Swastik Das, DAV Public School, Chandrasekhar, Bhubaneswar. Please come over the prize. The third prize goes to Ashish Priyadarshi of DAV Public School, Unit 8, Bhubaneswar. Sorry, the third prize goes to Chandan Sahu, ET Residential High School, Mangalpur, Dhenkanal. Higher Secondary School, Mangalpur, Dhenkanal. The next one is Bhuban Patra of PM Shri Kendra Vidyalaya number 1, Bhubaneswar.
Next, Ashish Priyadarshi, DAV Public School, Unit 8, Bhubaneswar. Pradyumna, DAV Public School, Chandrasekhar, Bhubaneswar. Pradyumna. Asif Mustaq, DAV Public School, Sector 6, CDA, Bhubaneswar. Asif Mustaq. Pranjal Pandey, PM Shri Kendriya Vidyalaya number 1, Bhubaneswar. Jannavi Samantray, DAV Public School, Sector 6, CDA, Qatar. Om Satvik Mahapatra, DAV Public School, Sector 6, CDA, Qatar. Subhankar Sahu, Tetrahedron Higher Secondary School, Tangi, Qatar. Subhankar Sahu. Tanvi Tapaswini Naik, DAV Public School, Chandrasekharpur, Bhubaneswar. Sneha Chaudhary, DAV Public School, Chandrasekharpur, Bhubaneswar. Vijay Sidhu Panda, Bhadrak Higher Secondary School, Bhadrak. This Olicam 24 was organized on 3rd November 2024, and then best 26 students are there. Now the list of coordinators who have conducted the Olicam exam: Devasis Parik, BJV Higher Secondary School, Bhubaneswar; Sushant Kumar Nath, PM Shri Kendriya Vidyalaya, Baleswar; Sushant Kumar Nath, PM Shri Kendriya Vidyalaya, Baleswar; Pushpasri Sahu, PM Shri Kendriya Vidyalaya, Sundargarh; Robinarayan Behera, PM Shri Kendriya Vidyalaya number 1, Bhubaneswar; Anupama Das, Dharanidhara Higher Secondary School, Keonjhar, Jogindra Satpathy, Vikas Higher Secondary School, Bargarh. Anybody who are present? Rakesh Kumar Shetty, DAV High School, Titlagarh. Subhash Chandra Assam, Mohan Subudhi College, Badampalata. Smriti Patnaik, UN Autonomous College. शशिकांत नायक, लोकनाथ महाविद्यालय केंद्रापड़ा. रमेश चंद्रपति, DAV पब्लिक स्कूल, चंद्रशेखरपुर, भुवनेश्वर. Stuart. Prakash Kumar Sahu, Deccanal Autonomous College, on behalf of Prakash Ma, Devashish Mahanti will receive.
Sponsor prize Devashish. Setting ko loe.
Setting karala sponsor. Sandhya Sayantini Mahanti of Stuart Science College. Sumitra Nandi, Rajendra Higher Secondary High School, Balangir, Women's College, Balangir. Any coordinator? Who college? Yes, Madam. Rajendra Higher Secondary, Balangir. Tetrahedron College. the student within base 20, Subhajit Bora from PM Sri Kendriya Vidyalaya number 1, Bhubaneswar. Any coordinator or students who are present?
Now it is Professor R.K. Nanda Award for Best Paper Presentation Oral. It goes to Pragati Vishwa. Now I request Professor A.C. Das to tell a few words about Professor R.K. Nanda. Pragati Vishwa of Niger.
I thank Orissa Chemical Society, especially Dr. Secretary or President and all executive members for giving me this opportunity to speak a few words regarding Professor R.K. Nanda. Professor R.K. Nanda was my teacher at the MSc level, and then he was my supervisor in PhD. Collaborator, I was his collaborator during his career in Utkal University, and probably around when did he retire? I forget. 90 he retired. And Nigam is there, who also was a very good collaborator and his student. And we developed a good research group with Nigam, myself, Achyuta, and yes, Murti Prabha, Ajay, and few Prakash Mahanti and Guruchan Pradhan, and it was a very nice group there to develop studies on reactions in solution phase in general of different types, usually mostly inorganic complexes to synthesize, characterize new compounds and study their properties in solutions so far as the mechanistic aspect is concerned. And also some way we also collaborated with Professor B. Das, Bhaskar Das, who actually was working in organic synthesis and application of the compounds in biological domain. There I also collaborated with the permission of Professor Nanda, my guru. In fact, I will go back to earlier days, coming to Utkal University, when I just joined in 1964 as a teacher. when Dr. Nanda came in 1 year after to coming from England, working in the group of Ingol on reaction mechanism. He gave me 2 books, one on inorganic reaction mechanism, another in organometallic synthesis and use. What we thought, myself and Professor Nanda, with his input, at those days, equilibrium and kinetic studies of organometallic compounds were very important. What we chose was the most deadly poisonous metal ions like tin and mercury to prepare or synthesize organomercurials and organotin compounds. I will cite to my young generations, I will cite one thing. Be very careful in handling such compounds if at all you are doing. Once Professor Nanda told me to synthesize tetraphenyl tin and convert it to triphenyl tin chloride or diphenyl tin dichloride. Use those as metal centers for synthesizing other organometallic compounds of tin and tin. And similarly, some organometallic compound of mercury. Regarding tin, I try to prepare tetraphenyl tin first by Grignard reaction. I did it myself, Grignard reaction, and then got the tetraphenyl tin. It was a hot day, so after preparing that, I tried to dry it and put it in the oven. It's a very beautiful crystal and sparkling crystal. Put it in the flame. I put it in the oven and went for a tea. When I came back, I thought it must be ready, it must be dry enough. And I opened the door, and once I opened the door, the temperature was beyond 100 degrees, and everything, you see, I found sticks, white sticks on the surface, on the upper surface, and vapors of tetraphenyl tin. I inhaled a lot. I did not feel, only I felt the smell of tetraphenyl tin. And next day when I came and I told him, sir, this happened. Now you see, you did the most dangerous thing, because tetraphenyl tin is a highly dangerous substance and you have inhaled a lot. Go home, drink some milk and try to, if you feel bad, then go to the hospital. But nothing happened, but only I inhaled that so. And next, what he said? He said, we will change our course of action. Our approach was prepare tetraphenyl tin and perform some redistribution reaction in tin stannous chloride, get diphenyl tin dichloride or triphenyl tin chloride, like that, and proceed. So we stopped there. He said we stopped that because already you have enough of tetraphenyl tin in your stomach or in your brain. So stop it there. It's highly poisonous. And then we'll go to small mercury compounds. That is another dangerous substance. So how do I prepare mercury compounds to study the reactions? So he said, that's a very easy method. Take mercury in a tube. Parma was there, who made a tube, glass tube, sealed tube, to take mercury, take methyl iodide, and put it in the ultraviolet lamp, and come 2 days or 3 days after, and then you break it open, and you get methyl mercuric iodide, and proceed the way you like. So that was his approach. And what I found, that when I completed this irradiation with a lamp, irradiation ultraviolet lamp, and got it, that was in the ISC gallery. Our that gallery, brother was there. So there was a cupboard. In that cupboard, this reaction happened, and then when I opened the tube, what happened? It had got methyl mercury iodide. It had got dimethyl mercury, which is high volatile. That I inhaled. Lot of it I inhaled. So that is the big problem. And then I did not. I felt very bad. But then I continued with that. I think those phenylethyl and dimethyl mercury stayed in my brain perhaps and swung up to me, yes, you have lost the memory quite significantly. That was the way things happened in early stage of my research. And that was Dr. Nanda. Then he came to Utkal University, and I joined there. We worked here. Very nice person, very friendly, and also takes very good care of research doing in the lab. Thank you very much for giving me this opportunity.
Valedictory, is he present? Please. Yeah. So his guide, I now request Professor Ekasa.
Arun should be my student. I am very glad to see you here and flourishing quite efficient.
He was my MD student. Oh. Thank you for teaching me last two.
Oh, long back.
Okay.
Mr. Vishal Raut, NIT Rourkela is conferred with Dr. Subhasin Lenka Best Poster Award for the year 2024. Okay, cash out of ₹3,000. I now request Dr. Satyaran Jena sir to tell some few words about Madam Lenka. She was present also in the inauguration.
Anyway, Madam Lenka was here on the inauguration day. Subhasin Lenka was a Ravensadian. She entire career of her life was spent in Orissa. A few years in Sodawada and RD Women's College. She did entirely. I have seen as a colleague in Orissa. She was a very good researcher in the area of polymer science. Dr. Samal happens to be working in the same lab. She was a very nice person. I think she is the first lady to get DSc from Ravenshaw College. From Ravenshaw College, she is the first lady to get the DSc degree. She, at the same time, when she went to Japan, at the same time I went to England, almost in the same year, 1989. Subhasin Madam is very student friendly, Madam. She is a good teacher. So the students of Subhasin Madam have instituted this prize when I was the president. And Asit Parija, I think, was the secretary. So the best poster presentation award has been instituted in her name. So that's all about First Lady President also for Orissa Chemical Society. And she attends almost all meetings. She comes wherever it is held, she attends the meeting. I think she has completed 80th year, and now a book. She has requested many former chemists of the state to give articles on him, and she rang me 10-15 times, and I have given an article in the memory of my favorite teacher and colleague, Subhasini Madam. That's all.
Thank you, sir. Vishal. And this year, OUTR has given 5 awards in addition to this for each oral and a poster. And now for best poster presentation oral, it is Miss Tanmaya Subudhi. Miss Tanmaya Subudhi. Sachit Kumar Das, BSSUD Burla. Is present Mr. Amit Sahu, OUTR Bhubaneswar. With a cash award of ₹1,000 each. Mr. Umakant Pradhan, OUTR Bhubaneswar. Shaturupa Panda, OUTR Bhubaneswar. Sorry, that's all. Subhasri Mahapatra, Utkal University. Subhasri Mahapatra, Utkal University. Come quickly. Sakhi Singh, IIT Bhubaneswar. Best poster, OUTR award. Sakhi Singh. Swagatika Malik, NIT Raulkela. Swagatika Malik, NIT Raulkela. Darshani Mahanti, OUTR Bhubaneswar. Shruti Sahu, Sambalpur University. Shruti Sahu, Sambalpur University. Now our labmate, Dr. Ruchalini Pradhan will receive it on behalf of her. On behalf of her, she is receiving. Once again, Sakhi Singh, IIT Bhubaneswar. Another is Shaturupa Panda, OUTR Bhubaneswar.
Thank you, ma'am. Thank you, everyone. Now, I would like to invite the dignitaries or guests to present their views on the conduct of this conference. So, first of all, I would like to invite the convener of Annual Conference on OCS and AIMS 2024.
actually invite the dignitaries as a guest, let their feedback or views on conduct of this conference. Then we can proceed. Very few, if anybody wants to give their feedback or views. Since we are delayed by almost an hour, so it is very limited to.
Dignitaries on the dais, my dear teachers. Really, it's a wonderful OCS meeting. Just I want to repeat what Ajay sir told me just few minutes back. He told Sarath the OCS meeting was excellent and VSS people this is like this. But I can tell this is better than VSS people like. And in all respects, I think it's a serious function. And whole OCS that tell, I have not seen any OCS meeting in where at the valedictory function in pura house. That's why it is a very good thing. And technical part, almost all speakers are very good, and that I came to know around 15 invited speakers and memorial lectures. If you think. Almost all around 25-30 lectures are already delivered. That's why I can tell it's excellent. Food is par excellent, and starting from the breakfast, all kind of like manda pitha and akra, and the end today is pura pitha. That is a very good. And the most unique part of this OCS is that it is declared as the Institute of Chemistry. Prime Minister. That's why it's a memorable OCS meeting. I will remember in Paripar. And I suggest the OUTR, such an excellent way they can manage it. Let them continue with a series of conference like us that we are doing at BSSOT. Every year they can organize national conference by which all the members are, mostly actually Bhubaneswar, we will able to see our senior teachers at least every year. We will organize as a series conference. Thank you.
कौन कहबी भल आरंभ करी सबू भल अच्युत को मार्क कर अच्युत मोर 6 वर्ष स्टूडेंट 4 वर्ष रेवेन्सा 2 वर्ष वाणी ये साइलेंट वर्कर कथा कम कहे किंतु काम किंतु बहुत लोग अच्छा कथा बेसी कहते काम कम करे किंतु से कम कथा काम भले करे आ समस्त श्रृंखला भितर से जहाँफल मु तो काली जाइनी मु गेस्ट हाउस रे थी आमे 3 जन बंधु गेस्ट हाउस रे रहिलु इंस्टीट्यूट ऑफ मैथमेटिक्स गेस्ट हाउस रे आ काली राती 12टा गोटे जाए विभिन्न विषय रे गपसप करू आ कॉन्फ्रेंस पूरा फ्लॉलेस हैला तनो लेट अस गिव ए बिग हैंड ये कॉन्फ्रेंस रे जो आरंभ हैला जे सीनियर टीचर से माने को लुमिनरी अवार्ड दे फेलिसिटेट करबा एटा ए कॉन्फ्रेंस रो आरंभ हैला आ सेटा उते बहुत भलो जिंस आ उते भलो जिंस इंस्टीट्यूट ऑफ केमिस्ट्री कवरेज आज भलो हिची आ हमें से इंस्टीट्यूट ऑफ मैथमेटिक्स रे रहतु से कैंपस रे से सकाळ मॉर्निंग वॉक रे जाई के देखिलु देखला पर बहुत जगह अछि जंगल पंगल एरिया हिची तेणु मु मोर दी बंधु कहली आ जो माने बीजेपी रे बहुत सक्रिय अछंती हमर पास्ट प्रेसिडेंट मु कहली एठी हमको 50 एकड़ देबे ए 50 एकड़ देले मैथमेटिक्स इंस्टीट्यूट ऑफ मैथमेटिक्स पाखरे इंस्टीट्यूट ऑफ केमिस्ट्री ही जाता देखा जाऊ कोन होची थैंक यू
Good afternoon, Governor North, editors here, esteemed guests on the dais, and all my respected teachers and all senior members of the OCS. and dear students. So the program like this, only the person those who are actually very efficient or very active in their administrative part also, like who has also with me from since 1986 where I have met, and then I am a regular visitor to this CET for different activities. So because of his involvement in different administrative capacity, and also he is very much associated with the authorities, and the program like this volume can be only conducted like this way. Otherwise, it is very difficult to person those are not actually involved in the administrative part. So this is one actually. If you see this, the type of program which has been conducted is no less than any other national conferences in any other places. So this is one thing. So we should congratulate the team, Orissa and other team. This is one thing. The other thing is that if we look last 10 years or so, the type of the presentations and other things, those were actually here in papers and other things, definitely the level has gone up. Whether it is poster presentations or oral presentations of our students, definitely it has gone up. So because of that a lot of institution has come up during last 10 years, whether it is NITs or IIT, either NITER, all institutions has come up. So that's why the competition level has also gone up. Particularly for state-funded university, we see that they are also like little bit their research has gone up. And thanks to the Odisha government, because last few years they are funding also some funding they are actually providing, particularly for that some of the students are there, faculty are actually getting some funds. Otherwise, the UGC has stopped funding, CSR has stopped funding, so there is no other way to get fund for state-funded institutions. Lot of NITs and IIT has come up, so whatever funds are actually getting a good research project from national level funding agency, it's now very difficult, almost extremely difficult. Because most of the lions shares are there, they are taking the NITs and IITs will take lions share. Hardly very few projects are actually left for state funded. So thanks to our government, because they have thought to give some project to the faculty of state funded university. So and because of that, and some fellowship also, because of that only, we are actually able to conduct some kind of research. So this is one thing, good thing. Maybe we can also propose to enhance little fund in that area, so that at least some people can get more funds. So this is one thing I can say, that the level has gone up. So that's why we should continue this level, so that there will be competitive always, and the research has also gone up. It can go at a high.
अजय बाबू, अच्युत बाबू, अजय अच्युत, रेणु प्रभा मैडम, पाखे बस स्मृति प्रभा, दी जन स्मृति मध्य बस विज्ञान आपण मैंने जहाँ ऑब्जर्व कले पाखापाखि से गोटे जिन ऑब्जर्व कर Achyuta is a volume of surprise. He is a man of surprise. He will act as if he is not going to do anything. The night before, जो दिन हम 28 तारीख 27 तारीख रात रे चेतनरंजन मिश्र मते फोन कले सबदर देखि के आसिले हॉलटा भलो सजा है बाहर तो कोठी देखिले नि बैनर बैनर लागिनी न लागिले पके तापर सकाळे आमी आसिलु 8 मिनिट बैनर रेड कार्पेट फुल सारिया ये सब सरप्राइज राखी सारा तो इमिदे अच्युत बाबू ताकर ये गोटे पिला ये दीर्घ दिन है सब काम ये इंटरफेस जोटे फोन कले अच्युत न मिले प्राइवेट सेक्रेटरी फोन कले से डिटेल इनफॉरमेशन दे ए जगह रचंती एठी नाती एटा हैछि एटा हैछि कोटा सार करचंती कोटा करनाती केति भूल जाय सब कथा ही जाय केति सब तेणु ओडिशा केमिकल सोसाइटी विषय मते रणप्रभा मैडम पचार इते बड़ सोसाइटीटा एठी कोन इते काम होचे मते टिके पचार लेटर नो we came to know that we are from the same district, Jashpur, and that's how there was a common point that I was telling her how the society has grown. It's more than how many years now? 38 years of existence, 1500, yes, 39 years, and more than 1200, 1500 members. And we have slowly grown to almost recognized as a national level organization now. Orissa Chemical Society has become known in many states. I have heard from many people from outside the state telling that this state level organization is almost like a national level organization now. So credit goes to all the former presidents. They have been working relentlessly for making it happen. I am sure this society will grow. Giving a speech in any conference and giving a speech in a OCS sponsored meeting or a OCS banner meeting, there is a difference. It's a state level organization and it carries significant pride in making your presence in the conference. So let us hope that this institution will grow further in NIT Raurkela. Things will happen under Smriti Prabha Madam and again Achyuta in a much bigger scale. We are sure it will give us many other good news, like we had a notional start of the Institute of Chemistry. We will have a real start of the Institute of Chemistry during our presidency of OCS. And now, finally, I would like to end my speech with a single point. Let us protect OCS. OCS has certain aims and objectives. It is formed on the principle of augmenting teaching and research in chemistry in the state of Orissa. That is its preamble. So let us protect that primary interest, and anything to run successfully means we require money. So let us protect OCS money, let its strength, foundations become stronger and stronger day and day as the days go by. So finally, I will, from my side, from the side of OCS, convey this message that this organization will be remembered for a very long time by all of us. This event will be remembered, and all of us, let us give a standing ovation to the members. Let us give a standing ovation to OUTR, to the Honorable Vice Chancellor sir, to all the dignitaries. Thank you very much.
Respected esteemed members of the class, मोर श्रद्धेय बंधुगण एवं छात्र छात्री स्नेहर छात्र छात्री मान आमर ये 26 तारीख दिन सन्धार आम आसीलु 4-5 जन बंधु इनक्लूडिंग डॉक्टर सामल चित्त भाईना प्रोफेसर जेना झील अमेरिका आसपे आसपार ना आम आसीलु से घरे मीटिंग है कौन केमती हम कौन नहीं समस्त एंजाइटी थी मंत्री मेसेजटा आसी कन्फर्मेशनटा बीसीबी टी एंजाइटी थे मेसेजटा आसिकार 7:30 बंधु दुर्वासा बंधु आम देखी नी 7:30 देखिए दुर्वासा कहूँ ତେଣୁ ଯେତେବେଳେ 7:30 ଦେଖିଲେ ଆମେ ଖୁସି ହେଇଗଲୁ, ଯାହା ମେସେଜ ଆସିଗଲା, ସବୁ କନଫର୍ମେସନ ହେଇଗଲା। ସେଦିନ ରାତି 9:45 ଗଲୁ। 27 ତାରିଖରେ as per the convention of OCS there must be an interactive meeting। ସେଇଟା ବି ସେଦିନ ହେଲା। ଆମେ ଆସିଲୁ 10ଟା ବେଳେ ଏଠୁ ଗଲୁ। 10ଟା ବେଳେ ଗଲାବେଳେ ଯାହା ମୋର ବନ୍ଧୁ ଡକ୍ଟର ସାମଲ କହିଗଲେ କିଛି ହେଇନି, କ'ଣ ହେଇଛି ଘଟଣା, ଏଠି ଗଲାବେଳକୁ ଏଇସବୁ ଲାଗିନି, କିନ୍ତୁ ତା ପର୍ଯ୍ୟନ୍ତ ଡକ୍ଟର ଆଚାର୍ଯ୍ୟ କ'ଣ ଏସବୁ କାମ କେତେବେଳେ ହେବ, ରାତି 1 ରହିଲା ନା ସାର୍ ହେଇଛି ମାନେ ବ୍ୟସ୍ତ ହୁଅନ୍ତୁ ନାହିଁ। କିନ୍ତୁ ତାପରେ ଦିନ ଆମେ ସକାଳେ ଆସିଲା ବେଳକୁ ଜେନା ମୁଁ ଆମେ ଦେଖିଲୁ ଭେରି ସରପ୍ରାଇଜ୍ଡ। ସେଥିପାଇଁ ଡକ୍ଟର ଆଚାର୍ଯ୍ୟ ଗୋଟେ ବିଗ୍ ହ୍ୟାଣ୍ଡ ଦେବା ସେ କେତେ ରାତିରେ କ'ଣ କଲେ ମାନେ ମୁଁ ଦେଖିକି ଆମେଜ୍ଡ। ଏଠିକାର ପିଲାମାନେ ଏତେ ସ୍ନେହୀ, ଏତେ ହସ୍ପିଟାଲ ଦେଖେଇଛନ୍ତି। ଭୁବନେଶ୍ୱର ଆମେ ଯେ ଆସୁଛୁ, ଆମେ କାଲି ରାତିରେ ରହିଲୁ Institute of Mathematics guest house. So thanks and a blessing to my students that they are so lovely and so affectionate. ये सबू सत्वे आ गोटे खाली सजेशन रहिला जे सॉरी आ गोटे कथा जे वाइस चांसलर जे मंत्री गले वाइस पचारले इसी कोन ओसीएस मेंबर मुखल नाही आज्ञा से ओसीएस रे फैक्टर काहे कि ना एठिकार वाइस चांसलर प्रोफेसर विश्वास जो टाइप रो इंस्टीट्यूट ऑफ केमिस्ट्री विषय कहिले नन ऑफ अस कैन प्रेजेंट लाइक दैट मोटा भारी। सो एक्चुअली इंस्टीट्यूट ऑफ केमिस्ट्री रो आरंभ जब देते इट गोज टू द क्रेडिट गोज टू द प्रोफेसर विश्वास राइट। सो लेट अस गिव अ बिग हैंड फॉर हिम एंड डॉक्टर आचार्य कन्वेमेंट बेस्ट रिगार्ड्स टू हिम। प्रोफेसर विश्वास जो टाइप रो प्रेजेंट कर मन बढ़िया भाबे चितलाई आज सेनापड़ देछि डॉक्टर सामल केक देछि तारन पेपर रे बाछि तोना हबो आमे सकाळ खोजुतलु जागा सिटी 50 एकड़ जागा कोड खोजुतलु इंस्टीट्यूट माथन प्रकार एनो दैट टेक अ स्टेप आई फ्यूचर सजेशन टू स्मृति मैडम जे लोकल एनआईटी रे जो लोकल कॉलेज को टी इन्वॉल्व करले आउटे बेटर पार्टिसिपेंट अधिकाटे होते कारण हमर 1200 लोक हेले 200 पैटर्न हेले लाइफ मेंबर 1200 बोली हमें बढ़ेलु लाइफ संख्या बढ़ेलु लाइफ मेंबर संख्या 8 ରୁ 12 करलु किंतु पार्टिसिपेंट के कम होचंदी एथि प्रति टिके दृष्टि देबा पई डॉक्टर आचार्य को टिके अनुरोध करूची मो स्मृति मैडम कहूची एवं हमर चीफ गेस्ट हमर रेणुप्रभा मैडम को धन्यवाद दउची एवं सब पिला माने पूर्ण करे श्रद्धा जुड़े रहउची। थैंक यू।
Okay, so without any formalities, thanks to all of you. I am from University of Hyderabad. I don't know the insights of how they make, how you do all these things. But scientifically, if you want to involve the research scholars, I wanted to announce two things here. University of Hyderabad has a networking research center constituted by UGC, but there is no support of UGC. And I am now from last 2 years as a coordinator because the responsibility has given on my head, and it is running very smoothly. University of Hyderabad houses all the instruments what you are not aware of. We have all instruments. We have 5 NMR machines, we have 3 X-ray facilities, we have HRMS, we have same time, all these things. HRTM, everything is there. So here I see that material chemistry and all these things. If any time always we think that we don't have this, we have the habit of telling we don't have this. But if you are interested, you come, write to NRC, and you spend some 1 month time or 15 days or 3 months, whatever is there, and you do all your sample testing, whatever is there, free of cost. There is no cost. So end of the day, you don't tell that one I don't have this or that. First. Second is this, as it is a Orissa Chemical Society and it has been very old, and as Sarah already mentioned, now I wanted to announce that if you are interested, that a RSC, Royal Society of Chemistry, to be part of your for some kind of assistance, like giving any kind of awards or something like that. As I'm one of the board member of RSC, where I visit every year to Cambridge and participate for the board member. And I would like to, very well, I would like to showcase, if you give a letter, I wanted to pursue that. And I will see that on how it will benefit in your activities.
We'll call you next year. We'll call you next year.
So, thank you all. And moreover, the research scholars who are there and working some colleges, whatever Orissa is giving, you are free to come to University of Hyderabad. Don't feel shy. World is now open enough. Do whatever you want. Publish good papers, work something good, no problem. There is no problem if you believe everything is possible. Thank you so much.
Thank you very much.
Thank you everyone for your inspirational words. Now I would like to invite the convener of Annual Conference of OCS and AMC 2024, Professor Vikyananjan Das sir, to please give his remarks.
Members on the dais, my teachers, participants, and my dear students. Actually, time भोक है समस्त को जान कर हमें एक्सपेक्ट करते थे मीटिंग टा वैलिडिक्टरी मीटिंग टा मते अधघंटा भीतर सरिजो किंतु सर माने जो फीडबैक देले ऑपरेशन सर जो फीडबैक देले सो हमें सेटा एक्सेप्ट करछु स्वाई सर कहले प्रति वर्ष कॉन्फ्रेंस करा जाऊ वी हैव ऑलरेडी दैट इज इन आवर माइंड डेफिनेटली हमें सेटा का आगे एक्चुअली आपण मानकर जते कहले भलो कहले हम माने ऑर्गेनाइजेशन दा बहुत भलो हेची दिस इज बिकॉज़ ऑफ आवर डेडिकेटेड स्टूडेंट्स एंड माय स्टाफ्स really they work hard all the credit goes to them दिन राती बसे से माने काम करछ मैं माने अछि हम कॉन्फ्रेंस ला 28 तारीख 26 तारीख राती 7:30 बेले पर्यंत चीफ गेस्ट किए बे हमें कंफर्म नै नथि 26 तारीख राती 7:30 कारण ता पूर्व मीटिंग रे डिसाइड हेतला चीफ मिनिस्टर चीफ गेस्ट हेबो बोली सर मन बहुत लागितले चीफ मिनिस्टर माने पे स्पेशली एसएम मानती सर परे न्यूज आसला जे अमित शाह आछंती हमें 100% श्योर है चीफ मिनिस्टर आसले कारण 28 29 30 फंक्शन अछि अमित शाह आछन चीफ मिनिस्टर आछन तापर अमित शाह को आसिया कैंसिल हे गला पुणी डाउट चीफ मिनिस्टर आसी एनीवे सर लागी मिनिस्टर हमारा साइंस एंड टेक्नोलॉजी मिनिस्टर को इनवाइट कले हमें 26 तारीख राती 7:30 बेले टाइम 27 तारीख संध्या बेले मीटिंग गोटे बसतिला कथावार्ता चलरे एसएन मान सर मते कहि देले ए तुम जे पर्यंत किछ करिनो केमति कोन करिवो ऑर्गेनाइज करिवो इट रियली सर विथ अप्राइज इट रियली हर्ट्स मी तो भारी दुख लागितला भारी कष्ट लागितला हमें एते परिश्रम करछु किंतु सर कहले तुम किछि करिनो मु टिके अवश्य सर मते क्षमा कर देबे मु आपन टिके ये हार्ड वॉइस माने उच्च स्वर रे कहि देतिली जे आपण सर देखिबे गल्ला बेले को देखिबे हमें कोन करिछु मीटिंग सरिला बेले को मतलब मीटिंग सरिला मेरे को 9:30 10 सर माने बाहर ला बेले को बोले चारिटा खंडे बड़ बड़ होर्डिंग लागि दिछि चारिटा पांचटा खंडे होर्डिंग लागि दिछि हां तबरे सर को कहली सर एबे आपण टी खुशी दना हो तथापि मोर डाउट अछि अरे आई एम ए मैन ऑफ डाउट मगर ठीक है सर हमें बहुत चेष्टा करछु सेदिन मते हमें हमर विश्वजीत मु राती 12:30 गोटे पाखा पाखी घर को जाइछु एवं हमर सबु पिला हॉस्टल परमिशन स्पेशल परमिशन दे हकते सबु पिला हमर रही की माने वेल अरेंजमेंट मो एक्चुअली आई एम वेरी मच प्राउड अबाउट माय स्टूडेंट्स माने एमिति पिला जहां कोई भी जतमे जहां कोई जो मोमेंट रे कोई समय आछन आई एम ग्रेटफुल टू देम मोर माने स्टूडेंट हेले भी आई एम ग्रेटफुल टू देम बिकॉज़ मते प्रत्येक स्टेज रे समय सहायता करछन एटा जनकर प्रोग्राम नुय एटा समस्तकर प्रोग्राम ओसीएस रो प्रोग्राम तनो हमें समस्त मिसी बहुत कष्ट करी करिछु एक्चुअली किए जण कहले गोटे झियो बागर बढिया लागुछि सत्तरे मु त आज के निश्वास नेली जे झियो बागर गोटे सइला नेक्स्ट वर्ष में हमें चिंता करिया कोन हो थैंक यू समस्त गोटे स्पेशल केस हला एठी हम ए प्रोग्राम रे ऑलमोस्ट समस्त सबु फॉर्मर प्रेसिडेंट जो मैंने अच्छा समस्ते ये आसते यहाँ आम यूनिवर्सिटी बड़ जिनस से आशीर्वाद आम यूनिवर्सिटी प्रति आम प्रति आशीर्वाद से बहुत बड़ जिनस आ गोटे बड़ स्टार्टिंग है ओडिशा केमिकल सॉरी ओडिशा केमिकल सोसाइटी इंस्टीट्यूट ऑफ केमिस्ट्री स्टार्टिंग पॉइंट देखा जो एसएन महांती सर को मुझे पुणी आउे विथ फोल्डेड हैंड रिक्वेस्ट करी एटा हेलो जते शीघ्र हम सेते भल कारण सर कर मोर जो कहते जन जन भीतर टिके बेसी रिपल्सन है से अट्रैक्शन भी बेसी हुए सर को मोर भीतर एमती बहुत कटा कथा कटाकटी बहुत होइछि तेणु बोध हुए आम दिजन भीतर से किसी अट्रैक्शन मुझे तो सर को मासिक थोड़ा निश्चय फोन करी केमती कौन करेंगे ऑर्गेनाइज करें थैंक यू आ गोटे रिक्वेस्ट था जो मैंने ओलिकम सेंटर कोऑर्डिनेटर जदि किसी फीडबैक देइतांते एटा भलो होइतांता कि किसी फीडबैक देले सेंटर कोऑर्डिनेटर जदि कि अछंती बा स्टूडेंट विनर जदि किसी अछंती किसी फीडबैक देइ पारे अल्प गोटे 2 मिनिट दियंते कारण भोक समस्त को होबनी एटा मते अच्छा ठीक है थैंक यू
आपण मानको समस्त को मत तरफ हार्दिक अभिनंदन मु खाली पदे बात कहबी मत सार कहले दुर्भाषा एक्सेप्ट जाए बहुत दिन रे कथा ओडिशा केमिकल सोसाइटी लोक बता करते आई एम हाईली पंक्चुअल आई बिलीव इन timely arrival of everything or timely conduct of everything. It can be a fault of me. Throughout my life I have suffered like anything in reaching the venue of anything in time or on time. Anyway, ये जो घटनाटी है आमर पॉलिटिकल लोक डाक मंत्री चीफ मिनिस्टर व्यवस्था नाला माने आम चिंता ना हे तो भगवान आम भितर बसिले मो माइंड को एटा आसिले 10-15 दिन तले गोटे मीटिंग होइतिला सेठी कहला पॉलिटिशियन चीफ मिनिस्टर आम मंत्री बा मुख्यमंत्री को डाकिबा मुख्यमंत्री को डाकिबा इज वेरी डिफिकल्ट टास्क बट नॉट डिफिकल्ट इन दिस गवर्नमेंट और बीजेपी गवर्नमेंट. That's why I said that the political लोग डाकिबा द लेट अस कॉल द चीफ मिनिस्टर से 3 दिन जाक इंसिडेंटली और टू आवर बैड लक और गुड लक आई डू नॉट नो एब्सेंट रहिले ओडिशा दिल्ली के जाइतले से पुडी आ पड़ गले इत्यादि यदि प्रेजेंट थांते से मध्य आसित बट अगेन I cannot say with certainty only when we get a communication from them or talk to them तापर का सर्टेनिटी आसी आमे कथा आउ जने रिप्रेजेंटेटिव से बेटी आसथिले बीजेपी लेवल ले तांकर आउट के दबदबा अधिक अछि हमर अध्यापक जने रिटायर्ड अध्यापक डेप्यूटी डायरेक्टर भी थिले आसथिले तांका दायित्व दे इंटेलेक्चुअल सेल तरफ बीजेपी रा बुद्धिजीवी प्रकोष्ठ अछि सेत्र मो मेंबर सार मेंबर और से भी मेंबर से तो जाई के हम कहदर चीफ मिनिस्टर पाखर बसी के कह देले नहीं सी एम नॉट अवेलेबल मु सब खर चिट्ठी पर चिट्ठी मगे ठीक है सीएम को पाई दीटा चिट्ठी दियो आउ मिनिस्टर पाई दे मिनिस्टर माने हला हम चाहे साइंस टेक्नोलॉजी मिनिस्टर आसी कारण ए उद्देश्य से तो आसी गला ये कथा जो दिन आसीबा हमें ठीक फंक्शन माने गला 28 तारिख दिन मु तार दिन कथा आइ जाई कहला सर केमति हम जिबा कहला मैं एजेंट जाई परम ना मु आसी मिनिस्टर को संगरे आगरे मु जिबी तापर मंत्री मु आसी ठीक पहुंच केतला आसे मु 10:30 से पहुंचबा 9:30 मिनिट पहुंच 9:30 नॉट 28 मिनिट रे मु मिनिस्टर का रेसिडेंस को एंटर किंतु साधारण पॉलिटिकल प्रेशर आई एम नॉट ब्लेमिंग एनीबॉडी एते प्रेशर भीतर थांती कोन से हमको भी कहि नांती से मो संगे देखा हला बळ प्राय 10टा परे भी गला 10टा हम तो टाइम देखा तो स्कोप ही ना याडू गनगन फोन जाउची केतल बारी हम सब रेडी मु बैठ कहिथिल मिनिस्टर हैज टू बी वेलकम द रिसीव्ड प्रॉपरली से मंत्री हो तो जियन यदि का हम बाहर गेस्ट करके डाकिले तांको प्रॉपरली रिसीव करबा हम समस्त दायित्व मोर असुविधा का कोन थला जो कहले ता दिन रात रे मेन गेट खोले मेन गेट इज अंडर रिपेयर हमें रिसीव करे मेन गेट पाखु एही प्रॉब्लम रो असुविधा थला आ केछा असुविधा सो सेटी डिसाइड हला केमते हमें रिसीव करे से बाहर ना एनीवे हमर आधा घंटा खंड देरी हेची से मते खोजिले जे सुरेंद्र साहब के ताकू डाक मु गली पदे दीप जे सर बाहर पड़े ना अपन खाइबे सर बाहर संग बाहर पड़ी कि सेठी के तथापि एपट सेपट बाहर लाल से खुजंती मु काई ताकर ड्राइवर मध्य मु फोन देते ड्राइवर एंड सिक्योरिटी ऑफिसर मते कोठी जे जान बाट एपट सेपट हे जिबा मते कहि आई विल गो इन फ्रंट ऑफ यू से जो कहले मते उठे फोन आसले मु से मंत्री को घर बाहर आसिकरी से उठे यू टर्न नहीं कि फेरिया पड़े जो जगह से रहते फॉरेस्ट पर रास्ता फिर आपन कोठी के ताको सिक्योरिटी ऑफिसर सर कोठी मु आपन आगे अछि आपन व्हीकल में देखा होता आप लागू कर so this is how we I escorted the minister and it's to my good luck that he has also declared it's like पदे कथा होता में सेठी जे जो केमती करते कथा कोन कथा सेठी सब कथा से कहे he is a very good minister very good person not like many other politicians so let us all take advantage of it वर्तमान के काम सरिले हमें चिट्ठी धर के जन इसकी जीवता दवा पे initial letter it's a good thing that has happened and let I pray God and any other almighty who are there above us हम कौन सी हिंदू माने 33 कोटि देवता समस्त को हमें प्रार्थना करिबा the Institute of Chemistry thank you all.
Thank you so much, sir. Now I would like to invite the Secretary, Orissa Chemical Society and Dean Academic Affairs, Professor Achyutananda Acharya, sir, to please give his talk.
Chief guest, respected Madam, Naik, Register, Orissa University of Technology and Research, President OCS 24, Professor Behera, sir, President-elect 25, Madam Das, Joint Secretary, Madam Patnaik, all my revered teachers, esteemed former president, invited guests, participants, and dear students. Organizing this type of conference actually need to have some administrative support or experience followed by your commitment to the subject. बहुत पूर्व सर मत अनेक सर कहते जे ओसीएस रो गोटे कॉन्फ्रेंस करो एनुअल कॉन्फ्रेंस जो पे कि मु 4-5 वर्ष धरी चेष्टा करथली जति हो एठी तेणु बड़ गैदरिंग हेले बहुत डर भी लगे 2005 रे मु जत चाकरी थली हठात गोटे चिट्ठी देने पाइली यू आर अपॉइंटेड एज सेक्रेटरी ओडिशा जॉइंट एंट्रेंस एग्जामिनेशन से तळु मोर परीक्षा विषय कौन से अभिज्ञता नथिला हाउ टू कंडक्ट एग्जाम मु सेटु प्रोफेसर दामोदर आचार्य भाई सत्र बीपीयूटी से वस्तले ही जस्ट जो प्रेजेंट विषय क्वेश्चन ताको से देखा कली सर मु ए परीक्षा काम पारिबे तो विषय मतलब कोइता अछि फर्स्ट क्वेश्चन कोइता कोन अछि मु तो परीक्षा करबे मोर कोइता माने जो माने जानि छथि प्रोफेसर दामोदर आचार्य को नॉर्मली नोबडी प्रोफेसर माने एटी मते जानथि हमर अछंती कली तांको जदी गाड़ी देखिले से जाय पछे नळा रे पसी जिवे किनु ता मु देखिबे एते रागी तेन कर पोइता अछि बोले हां सर पोइता अछि त ताल पारी मु सेटा बुझु पाली ने कोन ठीक अछि जने हमर आसु सर के भया दे चेयरमैन थिले जो चेईर से अतर से मिश्र आईआईटी सराकर डायरेक्टर थिले काहा को मु चिनी परीक्षा हला तापरे मु बसिली प्रोफेसर दियाचे जे रूम रे नॉर्मली एते डरंती मु सेठी बसि सब दिने गलाबल को ऑफिस रो प्रोफेसर दामोदर आचार्य निश्चय गोटे जोक कहियो दिस इज स्टेज लोक एते डरुचंती प्रोफेसर मैन डरुचंती कि सानी जोक को जने वेरी लिबरल तेणु बहुत जगह से गोटे एनी प्रॉब्लम गैदरिंग सबले फ्लो डायग्राम करिवे एवं बुझेबे व्हाट वी हैव टू प्रोसीड हाउ टू प्रोसीड I first learned how big gathering held, how you have to tackle, what are the things you have to do. Subsequently, JE chairman, secretary hela pare, mujhe जानली मोर कोइतार आवश्यकता कोन कारण सेतबे मेडिकल और इंजीनियरिंग परीक्षाटा जेई करथला भारी हाईली कॉन्फिडेंशियल सब क्वेश्चन कलेक्शन करबा डिस्ट्रीब्यूशन करबा एवं जो ओएमआर सीट आसीबो ताको कलेक्शन करिगिरी मु जो रूम रे रखिबी सेही रूम आगे रे चाबी पके मु सोई इट इज सो कॉन्फिडेंशियल कि टिके कोन हेले बहुत प्रकार असुविधा हमार संभावना रही दैट वी हैव टैकल नथिंग हैज हैपेंड तेणु 5 ରୁ 10 भितर से समय रही डिप्यूटी रजिस्टर रही डायरेक्टर एग्जामिनेशन रही सब रही देन ग्रेजुअली दैट प्रेशर आई टुक परीक्षा केमिति करा जिवो कोन करा जिवो एवं grace of God nothing has happened during examination for last 5 years because डिप्यूटी अंडर 150 टा प्राइवेट कॉलेज रे परीक्षा करी ता हैंडल करबा इज अ हेल ऑफ टास्क subsequently till today last 20 years मु टेक्निकल यूनिवर्सिटी डिप्यूटी सेठी मध्ये academic council member convener agenda minutes till today that has been मु जानि से केमति कोन सब गुडा कनी आसे सब गुडा कर मु academic council member coordinator एवं prepare the agenda present the meeting everything only all the basics ए जिनिसटा प्रोफेसर हमरो ओंकारनाथ माथि जे कि हमरो गोपीनाथ माथि कर बोथिले से सिखैतले हाउ यू हैव टू प्रिपेयर एजेंडा व्हाट यू हैव टू टेल एंड दीटा का नुआ यूनिवर्सिटी कारण डिप्यूटी आरंभ होला 2003 रे एवं सर्टिफिकेट फॉर्मेट केमति हो व्हाट सर्टिफिकेट हैज टू रिफ्लेक्ट दैट हैज बीन गिवन द ट्रेनिंग टू मी सेते एते परिश्रम करथली जा फल रे कि सब यूनिवर्सिटी स्टैट्यूट फर्स्ट स्टैट्यूट इज टू बी रिलीज्ड बाय द गवर्नमेंट विथ द सिग्नेचर ऑफ द प्रिंसिपल सेक्रेटरी so BPUT the state university their first statute was released by my signature first state university had the statute सेते गवर्नमेंट कहला जे secretary they जेहेतु you drafted it you prepared it the credit must goes to you and you signed it and released it that is how it has been released in the gazette तेणु से समय 5 ରୁ 10 भितर बहुत प्रकार जेते गवर्नमेंट रो केस government appointed me and deputed me to Supreme Court. I filed everything on behalf of government during that period. And here also, that his advice is whatever you are doing in any system, every year try to add some values to it. D80 chart nala pare mo admission to till completion their degree everything is coming under the academic affairs. Every year we updated and this year admission pay locus completely everything they uploaded all the documents fees everything uploaded and they are waiting time last year thila 2 घंटा ए वर्ष ला 2 घंटा next year we are planning for 10 minutes paperless admission for year that we are planning and जो पिला माने सर्टिफिकेट पास करछंती after the exam result is over all the certificate we are handed over with a packet and they go from this institute to accept the original one. So system updation is one of the mandatory thing. तेणु डिप्यूटी फेरला परे एठी एमएससी हमें स्टार्ट करलो 2013 रे फर्स्ट एमएससी इन केमिस्ट्री स्टार्ट हला 2013 डिप्यूटी अंदर कोनसी साइंस प्रोग्राम नाही समस्तंगर धारणा जे टेक्निकल यूनिवर्सिटी केवल इंजीनियरिंग या एमबीए प्रोग्राम चलियो साइंस प्रोग्राम चलिबोनी तेणु आई यूज माय एडमिनिस्ट्रेटिव एक्सपीरियंस जे टेक्निकल यूनिवर्सिटी साइंस प्रोग्राम छडा ह्यूमैनिटीज प्रोग्राम मध्ये स्टार्ट हे परबो दैट इज द प्रोविजन ऑफ द एक्ट तेणु विथ दैट एवरीबॉडी गवर्नमेंट हैज अप्रूव्ड एंड 2014 वी हैव आल्सो स्टार्टेड इंटीग्रेटेड एमएससी आ जो 5 जण मोर सेठी थिले जे कि सब एकेडमिक प्रोग्राम रे दे हैव कंट्रीब्यूटेड वन इज हमर सर अछंती प्रोफेसर अशोक मिश्र सर प्रोफेसर विष्णु पटेल हिमांशु विश्वाल एंड निवानंद दास ए 5 जण को एनी एकेडमिक इवेंट वी आर दिस 5 विथ दिस पिलर वी एडेड अप एनीथिंग एंड गो अहेड एंड जेतेबे मु नेली एवर्स आमे करिउ बोली ओसीएस then mo service sample same OCS करिउ annual function ता सहित गोटे थीम हमें दबा जोटा कि नेशनल कॉन्फ्रेंस हो तो सार कर मोर कन्वर्सेशन हला विथ what are the theme to be presented तो सार देला परे फाइनली वी अराइव दैट नेम शुड बी एडवांसमेंट इन मटेरियल केमिस्ट्री दर्शक सर कहि तापरे हमें कहलु जे ठीक है जेटा हबो देन वी वेंट ज्ञानकर मोर पुण्येन्दु बाबू पाक रेवेन्सा रे केते बजेट कौन हो ना बजेट पाखापाखि 9 लाख ऊपर खर्च हो तेणु आसला डिपार्टमेंट मीटिंग गलु जदि फंडिंग न मिले कौट कौन कर गोटे काम कर समस्त जिते डिपार्टमेंट एंड फैकल्टी अच्छे समस्त मसक दरमा मिसेद इट इज मोर देन 10 lakhs तेणु जब किसी न मिले be prepared that we have to contribute 1 month salary then we can conduct it we'll do it with that motive we started and vice chancellor सबले पॉजिटिव थिले एवं जहाँ जोटी फाइनेंशियल इशू हो कि लेटर्स टू गवर्नमेंट वाइस चांसलर पैटर्न मध्ये हम मागिचु स्पॉन्सरशिप पई प्लीज काइंडली इन दैट रिगार्ड मैडम मध्ये बहुत सहायता करछंती टू हेल्प हाउ टू गेट द फंड्स फ्रॉम द गवर्नमेंट तेणु जहाँफल कि किसी फंड्स विभिन्न सोर्स रु आछि बीसी कर एक्टिविटी अछि मैडम मध्ये कहिसंती I used my influence also to get some funds. We get some from government agency and private agency also. Maybe deficit he pare then we can see how this can be make up later on. The program mostly did is our more 4-5 email account. I don't know. I with big apology. And सब mail ले पाखा पाखी दिन को 50-100 आसीबो ताकू मु चेक करिया संभव न जो OCS secretary mail is operated by President. So I give instruction what to do, what not to do. Similarly, Dean Academic Affairs, every day we get around 200 mails. So another person from my academic section, I have given this is the instruction, you have to follow and give the reply quickly. So that thing we are believing on the juniors. So same thing from the Professor Damodar Acharya, we have a flow chart what we have to do only because जेतले मु जेई रे करिछि 70000 पिला को ऑल ओडिसा बाहर मध्ये परीक्षा हेछि ओडिसा बाहर तेणु ए ओनली गेम 3000 4000 पिला को परीक्षा करिवारे मोर एतटा नाही ओनली डिफरेंस इज पीपल मे नॉट कोऑपरेट बिकॉज़ दिस इज नॉट अ गवर्नमेंट स्पॉन्सर्ड प्रोग्राम we can point this is the status to go ahead any difficulty I will be there he has taken a lot of pain to coordinate this only game so that more than 3000 students funding base to Ajay sir mate पठेले ओडिशा हायर एजुकेशन काउंसिल द नोटिफिकेशन जे तुमे सेटा 3 दिन कले जाई पैसा मिलियो न मिलियो मगले तो ओडिशा केमिकल से 2 दिन एनुअल कंपनी आपण 3 दिन कले से 9 लाख 12 लाख पहुंचो ए 3 दिन कले एवरीबॉडी विल ऑब्जेक्ट नै किछि नै तुम 2 दिन करियो नै 3 दिन कले ही मु कथा का करछि अशोक भाई न सहित से पैसा दे then we went to higher education council the condition was you have to not include the OCS our lectures only give 12 names with their consent खाली ना देथिले हम देके कर देथांतो दी दिन से कहथिले with consent you have to submit that is why we submitted the application with consent जा फल कि हमके एटा बाध्य हला जे 2 दिन रु 3 दिन करिया पय तापरे सब्सिक्वेंटली जेते गोटे चीफ गेस्ट कथा आसला से भाइस चांसलर सहित डिस्कशन हला भाइस चांसलर कहले तुमे गोटे एभली लोक डाको जे कि इंडिया फेमस तार ना तार जहा एक्सपेंसेस यूनिवर्सिटी विल बियर मु इमीडिएटली अशोक सर को लगाई फोन सर मते दिने समय दियंतु अशोक सर से 2 जन का नाम देले कहले केजी थॉमस फ्रॉम आइजर केरल त्रिवेंद्रम एंड अनदर इज नारायण प्रधान well नारायण प्रधान has already given to consent he is coming केजी थॉमस तो ना इतने सुने नहीं किंतु just like you call somebody like CNR राव और गोवर्धन मेहता मु सारंग सहित बहुत डिस्कशन पड़े देखली जे आवश्यक के सुइटेबल ना सेम आसुना दी जोटा कि से नाटा विषय के सुनि ना दी बा से राज्य हेलनी तापरे with discussion he is telling why don't you call Eventra VC or IMT director then he has taken interest otherwise I have the impression the vice chancellor will the chief guest register other people will be there so we can start the academic program because if you call many people then your academic program will be delayed because in OCS we don't have any provision at that time to invite any political people so I also have that in mind so anyhow with this all the 19 former presidents. They have came to our campus. For that I am grateful to all of them, all my teachers and my seniors, everybody came. I was panicked when 1 week before there is a rain. I sir कहली sir वर्षा जदि हेइबा बहुत हैरान हेइबा. Sir कहले जदि it be natural calamity ताले nobody can help you. But we planned what to do, and accordingly by the grace of God things have run smoothly. I hope जे कहीं कहार असुविधा विशेष है न तो एक्सेप्ट ट्रांसपोर्टेशन. तेणु सारंकर गुरु प्रोफेसर ऋषिदास सारंकर जो ट्रेनिंग जहाँ मैं सीखी, if you have a dedication, ultimately at the end you get the result. तेणु परिश्रम कम कथा कही सार जोटा कहले इट इज ट्रू. प्लानिंग करी बेसी सबऑर्डिनेट मानकु ड्यूटी असाइन करी ले ही कामटा हेई परिबो. कारण एडी डीन ऑफिस रे एते काम जे मु 5 जण जूनियर टीचर को नै कि सब काम डिस्ट्रीब्यूट करे पछ. तेणु दैट इज आई ऑलवेज बिलीव इन देम. In that way, I don't know if any lapses from our side. I beg apology to all of you. And एठी मध्यम समस्ते आसिले all the teachers. सेति पई मु मध्यम institute रो all the authorities, myself, I am thankful to all of them. एवं institute केमिस्ट्री होबा पई सेकंड सैटरडे डिसेंबर मास रे ससदर सर कहले जे मु विसिंग देखा करी. सेकंड सैटरडे छुट्टी हमर एठी आ निहाते अर्जेंट अछि मोर विषय सारे कथा हो. मु सेतु जानि नि इंस्टीट्यूट ऑफ केमिस्ट्री कथा कोन. तेणु विसिंग फोन करी जे हमर फॉर्मर प्रेसिडेंट सर जो चाहू छने आपन को अर्जेंट देखा करिवे ना काहे कि मु विषय मु जानि कि से चाहू छन. तो निहाते दरकार न हां सर आपन आसो भाई छन आसीले छुट्टी दिन रे आसीले. आपन कहले आपन पहुंचला पर मत फोन करिवे. मु फोन करी पीसी आसीले ससदर सरकार पहुंचले आसिक वी हैव डिस्कस्ड. देन आई टॉक द चीफ मिनिस्टर को गोटे डाकिया पड़ियो. देन आई डिस्कस्ड विथ माय कनेक्शन विथ द सीएम ऑफिस व्हाट इज द अरेंजमेंट और अपॉइंटमेंट ऑफ द सीएम. देन बीसी देले जे 16 तारिख दिन चीफ मिनिस्टर ऑफिस देले जे 16 तारिख डिसेंबर 9टा बेले अपॉइंटमेंट मिलला. 9टा बेले भिसिंगर मोर सकाळ जाइगिरी सीएम का रेसिडेंस आगे ठिया 9टा ରୁ 10टा भिसी ठिया है जन स्टैंडिंग. नोबडी अलाउड टू गो इनसाइड. जे भाई चीफ मिनिस्टर उठी ना तेणु दी जन ठिया 9टा ରୁ 10टा बेले से टू हमको अलाउ कले टू गो इनसाइड बट नॉट इनसाइड हिज हाउस, आउटसाइड द हाउस. रास्ता को भीतर को गलो किंतु भीतर को जाई पालो. फाइनली व्हेन यू ट्राई टू एंटर इन देखा करियो. तेणु मन दुख हला जे बीसी घंटाटे थिया हेले रास्ता रे किंतु देखा ही पल्लानी जा हला. बीसींगर से दिन थाई गोटे सीबी रमन कॉलेज रो बोर्ड मीटिंग दिन 9टा रे जोडी की सेक्रेटरी माने आसुतले एवं मु तन कहि कि मु नै आपण 10:30 करंतु चीफ मिनिस्टर प्रोग्राम आगो. मीटिंग वाज शिफ्टेड विथ माय रिक्वेस्ट. किंतु सबले कहला कथा जे विसिंगर कोठी हमर केमिस्ट्री प्रोग्राम हबो ए जिंस हम करूछु. वी हैव ब्रीफ देम. ही नेवर सेड नो एट एनी पॉइंट ऑफ टाइम. एंड प्रोग्राम रे जहा जोटी दरकार मैडम रेस्टरूम कहिछि सर मैडम ए जिंस दरकार ऑल द थिंग्स शी इज ऑलवेज पॉजिटिव. तो ए जिंस जहा हेछि आई गिव द क्रेडिट टू बोथ माय वाइस चांसलर एंड रजिस्टर फॉर व्हिच दिस प्रोग्राम इज सक्सेसफुल. आई एम थैंक टू ऑल माय टीचर्स. And we are delayed in time. That I told my students to serve the cake and your chena poda tale calorie kichi paila adha ghanta hu to ghunchi he jibo. Tale time is too late. Thank you everybody. Thank you.
Thank you so much sir for your kind words. Now I would like to invite the President of Orissa Chemical Society 2024, Professor Ajay Kumar Behera sir, to give his remarks.
OUTR कुल सचिव माननीय रेणु प्रभु नायक, मंचासीन अतिथिवृंद, सामने बसी मोर पूज्य गुरु अनय चरण दास एवं पूर्वतन वरेण्य पूर्वतन सभापति ओडिशा केमिकल सोसाइटी एवं छात्र छात्री माने एवं डेलीगेट्स गोटे कॉन्फ्रेंस करवा केते कष्टकर ताहा हमर सेक्रेटरी वर्णना करछन से मु जते बेले 24 रो 5 तारिख रे प्रेसिडेंट रो इलेक्शन हैला से दिन ठु सीरियस हेली जते सोया पूर्व मो अधघंटे भाबे ओडिशा केमिकल सोसाइटी कोन करि पारि दुनिया प्रोग्राम अछि से प्रथमे रीजनल कॉन्फ्रेंस पे मु 3-4टा कॉलेज कांटेक्ट करथिली सेथिरे बरगढ़ कॉलेज से मो स्टूडेंट थिला सुशांत प्रधान विजय साकर ताकू कहबा सुंदर को भी कहबा से करबो बरगढ़ जेला हम गलु मु विजय सार नै जाइथिली मु गल गोटे डिस्कशन करू ठीक सार कर दो गल पैसा पत्र पाइबो हां सर पैसा पत्र मिल जिवो तापरे से डिपार्टमेंट आसे ताको हम हेल्प करू पठिया पे 4-5 मास परे से माने किसी कहूना बोले हबो हां सर हबो पैसा नै सर हबो से बुझियो बाहर कर पना बोले ताले कोन करबो एटो तापर से बहुत कष्ट रे बाहर करे पैसा न होले कोन करबो सर पैसा न होले हाथ में दबो कोन कर एई टाइप रो का पैसा देले के पैसा दउ नांती सेथरे थरे जाइथिलु गाड़ी की तापर आउ थरे डिपार्टमेंट लोक नै गली फाइनली प्रिपरेटरी ऑफ द मीटिंग रीजनल कॉन्फ्रेंस तापर से माने सेई टाइप रो कले पॉलिटिकल लोक डाकिबे काना पैसा किछि पाइ बोली पॉलिटिकल लोक आसिले नाही हम जेतु डिले हला सेठी से जाओ I thanks Sushant Pradhan and another student Sipun Sethi for nicely conducting the regional conference of Orissa Chemical Society there. सेतरे बहुत फॉर्मर प्रेसिडेंट एक्टिविटीज ना बढ़ी जाइछि एक्सटेंडेड लेक्चर सीरीज OCS इंडस्ट्री इंटरफेस जाओ सेतरे मु प्रथमे कोडी करबी कोन करबी समते कर भुवनेश्वर हमर रेजुलेशन देला इसी रे जे भुवनेश्वर ले भलो हो भुवनेश्वर एटू मु कहली गट स्टूडेंट अछि अनिता पति सो अनिता पति की मु कहली कहले एटा गोटे भुवनेश्वर कल हबो सर करबी जे एटू ससदर कल रॉयल सोसाइटी पैसा दबो रॉयल सोसाइटी माने केही चिन्हन्तिनी से कल किड्स केवल चिन्हुची रॉयल सोसाइटी बोले एटा करो तने बहुत डिस्कशन परे से राजी हेले मझे हमर प्रोफेसर आचार्य देखि अच्युत सामंत को भेटि थिले एमती करिया जाओ से गोटे सक्सेस हैला फर्स्ट टाइम पई फिजिकल मोड रे हमर OCS इंडस्ट्री मीट हैला ओडिशा केमिकल सोसाइटी तरफ and it's a great thing because we were thinking about the students we were thinking about the career of the students future career of the students तेनु सेति पे समान सेति कले एवं OCS रे गोटे सक्सेस हैला तीटा एक्सटेंडेड लेक्चर सीरीज जानि एक्सटेंडेड लेक्चर सीरीज कोन हो पीटी सेंटर आइतो आ पिलांग सेठी हमें करिवु एक्सटेंडेड लेक्चर सीरीज सेठी के माने से माने कांटेक्ट करि परबे तंगा पैसा नहीं एवं आमे से कहले आमे स्पीकर नै जिवो निजे सेक्रेटरी हो OCS प्रेसिडेंट हो आमे स्पीकर नै जिवो सेंट्रल सर हम कर दो कनु मु जानि हम दि तीनटा जगह करथुलु से अच्युत बाबू कले भद्रक कॉलेज से राजी हेले मु बलांगी राजेंद्र कॉलेज यूनिवर्सिटी को कहली से माने कहला सर हम करिवु तो I were selected speaker and they have also selected speaker from Bhubaneswar नेक सेठी गले बट very unique things are there जे बहुत दिन हला पर कॉन्फ्रेंस नहला बडा पिला फील करथिले एवं ये एक्सटेंडेड लेक्चर सीरीज पिला न खाय की भोको भूली जाय की से माने पाठ सुनथिले सेटा एक ग्रेट अचीवमेंट ऑफ ओडिशा केमिकल सोसाइटी बलांगी रे 30 पर्यंत पिला खाय जाउथिले एवं इंटरैक्ट करथिले विथ द स्पीकर्स सो यस सर So that what I mean. So now we have this time many students, research scholars have applied for awards. I thank the award committee members, particularly Professor Satyavan Jena, Professor Sasada Samal, Professor Sarat Das, and Professor Vijay Mishra for taking effort. 2 days evaluation is there, the first time in the history. 2 days evaluation and they have selected the good candidates for the award, different awards. And then actually what happens, this conference particularly is very memorable because jete presidents achunti sabu presidents a meeting re asthile बोधे भविष्य एटा केबे हबो नाही कि आगरु केबे हेई नथिला जेते जीवित अछुनी जेते प्रेसिडेंट्स रहिसंती सबु प्रेसिडेंट्स ए कॉन्फ्रेंस आसिंती दैट इज यूनिक इन दिस कॉन्फ्रेंस and so far the academic program they have told it is fine. Transportation little bit problem with this location but it's okay. Fooding is very good, Orissa foods, so no specially kakra and podopitha and mondai, these are short. And cultural programs very excellent yesterday, and so for this program I must thank to the organizers right from Achyutananda Acharya to the students, and basically I express my heartfelt thanks to the Vice Chancellor Bhubaneswar for his extensive cooperation for making this program a grand success. Bhubaneswar, and very nice man, very gentleman. And I have told that many people have told Achyutananda Acharya. Initially, I think that when I call a phone, then it didn't receive the phone. What, there is busy actually, some meetings and everything. Then I thought, so then I actually I think that how we can conduct this annual conference, but actually silent worker and no response, but work was being done very seriously inside. No visibility is there, but work is done. So thank you, Secretary and organizing convener that Bigyanandan Das, and also I forget that the Olympiad, because the new team is there, so all have done a marvelous job enrolling the record number of students here. So thank you Bigyanandan Das, Priyaranjan Mahapatra and Bigyanandan Dali and other members of the committee. So then actually I express my heartfelt thanks to all the former presidents of Orissa Chemical Society. Those have helped me a lot for making this function a grand success. Especially Sasadar Samal, especially S.N. Mahanti, Ashutosh Samantray, Professor Satyavan Jena and Sharad Das. They have helped a lot for the success of this one. Unique this one, the birthday of Institute of Chemistry has taken place this year. Actually, we can try and we hope that Institute of Chemistry may be safe in future in our state. Now, I thank also our Honorable Minister Krishnachandra Patra, Food Suppliers and Consumer Welfare, Science and Technology, Government of Orissa, for his commitment to build this Institute of Chemistry in our state. So in absent, big hands to Professor Krishnachandra Patra, the Minister, for his commitment and for making this institution in this state. And finally, all the student volunteers, all the faculty members, basically the faculty members are there, guest faculties are there, many in this department. So I express my heartfelt thanks to all the faculty members, guest faculty, students here for making this function a grand success. Now what I have seen that the media and the press, because wide coverage is there of this Orissa Chemical Society, 38th annual conference of the society. So in this meeting I express my heartfelt thanks to the media and electronic persons for wide coverage of this program in very national, state and national newspapers. So I again thank all the executive members and the delegates. Those presence actually has made this function a grand success. Thank you all.
Thank you so much, sir. Now I would like to invite the President-elect Orissa Chemical Society 2025, Professor Smriti Das ma'am, to give her remarks.
Dignitaries on the dais and of the dais, mo sir mane, our sabu Orissa Chemical Society members. I am very much thankful to all of you, especially the seniors, to select me as the president of Orissa Chemical Society. Thank you so much. But more observation ete barsara kiye president hochi, that is not so important. She kemti kaam karuchi ଆମ society ବୋଲି କହିଲି କାନା ଓଡ଼ିଶା କେମିକାଲ ସୋସାଇଟି ନା କହିଲେ ମତେ ଲାଗେ ଯେମିତି ମୋର ବିଜର ତ ଆମ ସୋସାଇଟିର ଡିଗ୍ନିଟି କେମିତି ଠିକ ରହୁଛି, ଆମ ସୋସାଇଟିର ଆକ୍ଟିଭିଟିଜ କେମିତି ପରଫେକ୍ଟଲି ସିମିଲାର ଅର୍ ବେଟର ଦେନ୍ ଅଲ୍ ଦ ନ୍ୟାସନାଲ ସୋସାଇଟିଜ ରହୁଛି, ଦ୍ୟାଟ୍ ଇଜ ଆୱାର ପ୍ରାଇଡ୍। ସୋ ମୁଁ ସବୁ ସିନିୟର ମାନଙ୍କର ଆଶୀର୍ବାଦ ଭିକ୍ଷା କରୁଛି ଯେମିତି ଆମ ପ୍ରାଇଡ୍ ଆମ ଡିଗ୍ନିଟି ए वर्ष सारा मु ठीक रखी पारे। जदि सेटा मु करि पारली, आई डोंट नो हाउ फार आई विल बी सक्सेसफुल इन दैट एस्पेक्ट, बट जदि सेटा हे पारिला, देन आई थिंक बीइंग द प्रेसिडेंट ऑफ दिस सोसाइटी आई कैन डू माय कंट्रीब्यूशन। ए सोसाइटी में डर नाही केना आगरे मुंड ऊपर सब बेले हाथ रहउची सीनियर मानकर। हमर प्रीवियस प्रेसिडेंट माने सब बेले रेडी अछथि हम एडवाइस देबाकू, स्पेशली हमर डाउट मैन सब बेले अछथि लूपहोल बाहर करबाकू। सो आई विल रेस्पेक्ट अगेन आई एम सेइंग, बिकॉज़ मु ताकू सब बेले गाली दिए एकमात्र लोक, किंतु रेस्पेक्ट दिए एथि पई कि काना से डाउट ता ही बाहर करंती। अन्य मन तो डाउट बाहर करंती, अन्य माने प्रेस करंती। प्रेस करबा अपेक्षा डाउट करबा लोक सब बेले भलो, काना हम लूपहोल ता हम जानि पारबा। लेकिन मु डाउट मैन को सब बेले वर्ष जाक फोन करबी, इंस्टीट्यूट ऑफ केमिस्ट्री को दिन हबो, काना इंस्टीट्यूट ऑफ केमिस्ट्री हबार दायित्व से नै छथि बोली कहि सारलेनी स्टेज ऊपर को नथिले रहितिले बहुत पछरे आसी कहि देले, आ सेटर एडवांटेज मु निश्चय नेबी। वर्ष सारा तांको वर्ष इते देबेनी हमर इंस्टीट्यूट ऑफ फिजिक्स इंस्टीट्यूट ऑफ केमिस्ट्री हबा दरकार आ भलरे हबा दरकार। एंड आउ कोन कहबी, मोर समय नंबर नाही कारण समस्त को भारी भूख, समय भी देरी हलानी। गोटे कथा खाली कहबी, अच्युत बोली कहूचे, आई एम सॉरी से बड़ लोक किंतु अच्युत बोली डाकी आसी मोडरू बहुत दिन एसोसिएशन ता संगे ताको सेक्रेटरी हेबा पे मु कन्विंस करिथिली, से मते मना कला नाही सुतेबा मु एतरे फसिबी। तापर अनाथ सर को फोन कली, सार टिके ताको कन्विंस करंतु, से राजी होउनी गायना मते टिके मो मुंडो रे कन्फ्यूजन संदर सर पुरी देली। सी गोटे सीनियर लोकटा ता कोन कोजो हबाकू सार कहले ना ना से हबो, एना मोर तारो कैपेबिलिटी ऊपर 105% विश्वास थिला से करि पारिबो। सो ही हैज डन इट, ही हैज प्रूव्ड दैट ही इज अप टू द कॉन्फिडेंस ऑफ ऑल द सीनियर्स, जोटा कि किछि लोक ता कम कथरे टिके डाउट करूथिले। एंड आई वांट ए बिग applause for him। समस्त को धन्यवाद। आई होप आर वर्ष जेतबे आमे करिबा सब दिन से ठीक ठाक चली थाउ। जगन्नाथ समस्त को हेल्प करंतु आ बड़ मान का आशीर्वाद लो। नमस्कार।
Thanks a lot, ma'am. Now I would like to invite our chief guest of this function, Mrs. Renuprabha Nayak, Madam Registrar OUTR, to grace the occasion.
Very good afternoon. First, in my opinion, I do not deserve to be chief guest in this forum. Thanks to the School of Basic Science and Humanities. They have given me this role, for which I think much above my intelligence, competency, and something beyond this. So this is a very pleasurable and very precious moment for our university. And in this nascent and baby stage of our university, such a nice, such a fantastic conference. For the first time within my 1 year, I have seen here the consecutive 3 days conference with the 38th annual conference of the OCS and along with the National Conference for Advancement in Material Chemistry. Actually, I am not a student of science, I am a student of political science. So, chemistry is much beyond my understanding and knowledge. But being an administrator, whatever problems we are facing in the society, within these 2-3 hours of my listening of some of the presentations, so I got some ideas and my sincere appeal to all the luminaries, stars of chemical society present here. From our side, our appeal will be, suppose I am giving some instances during 25 years of my administrative service. People are dying using the spurious liquors. And people are dying in carcinoma that we have heard from the nano polymers given by our esteemed professor from IIT Bhubaneswar. People are dying using that illicit liquors, and also some kidney diseases because of the pollutant, I think water, and also farmers are also dying because of the pest attack of their agricultural product. So, where lies the solution? Everywhere the administrators are being blamed, the administration is being blamed for all those incident happenings, disastrous happenings. But the solution lies where there is a problem, there is a solution, and solution lies with you little our esteemed God. How could we minimize the sufferings of the human society? Because the ultimate goal of science and technology and every action, maybe administration, maybe research, maybe politics, is the human welfare. Maybe at the personal level, maybe at the family level, maybe at the societal level. But always we think that this universe is human-centric, but this is not a human-centric. Once Einstein told that, even we all know that if all the animals and insects will perish, vanish from this university, then what will happen to the human being? What will happen? Can we survive? So you might know, you are much better, intelligent people than me. But if the human beings will vanish from the universe, then how our universe would be? So this is a very concern. Now we are passing through a very critical stage of human disasters, and how we could mitigate this. How very sensitively handling our lifestyles, how very sensitively manufacturing the products and using of those products. And I think in this field, the science, the technology, that plays a pivotal role in uplifting and mitigating the human disasters. And I am very much glad, actually, what everybody has taken the opinion that our School of Basic Science, particularly led by Dean Acharya Sir and Vigyan Sir and their team, they have done a marvelous job here by very nicely and very smoothly arranging this 3 days conference. And this is a very pleasurable moment for our university also. OCS has selected our university to arrange their 38th annual conference. And I also give very much thanks to the present president and also the elected president and also the secretary and our vice president, madam, and all those you are leading a very sincere effort. And what our honorable minister just declared 2 days back, that is opening of the Institute of Chemistry for Orissa. Really, this will be a beacon light for leading a greater research for all the, I think, all the people, for the, particularly in the academic side and for the research side, not only in the chemistry but flourishing the inter-departmental relation in coordination with the industry people, in coordination with the academicians, in coordination with the administrator. Being a little official here in the Orissa government, I am giving assurance in this forum that whatever possible on my part, because there are 13 years of job of me, in whatever way possible, definitely I will extend all sort of cooperation and all sort of coordination and all sort of my personal effort, even if I am here in this university or may not be in this university, elsewhere in any government, any department, I will have a very patronage and very cordial approach toward the OCS till I am alive. So I won't take much time because research has no ending and the knowledge has also no ending, and our sir doubt that really science is always based on the doubts. When we think that I know, then there is a depth of our knowledge and curiosity to know something. So it's better always think that I do not know anything. I do not know anything. That will just unravel one horizon of knowledge and intelligence for all of us. And lastly, I wish all the thanks and all the prosperity and all the progress for OCS and for your personal life and for your professional life. Thank you.
Thank you so much, ma'am. Now I would like to request the senior most professor, Professor A.C. Das sir, to please come over the dais. And I would also like to request our chief guest to kindly felicitate Professor A.C. Das sir.
I am just a member of dignity and honor. Thank you very much. Thanks to the second all. And I will help as well as I can.
Thank you so much, sir, for being inspirational for all of us. Now, I would like to request the President of Orissa Chemical Society, Professor Ajay Kumar Behera, sir, to kindly felicitate our chief guest, Mrs. Renupada Nayak, madam. I would also request sir to kindly felicitate the elected president of OCS, Dr. Smrutipada Das ma'am. I request sir to felicitate the Joint Secretary OCS 2024, Dr. Smriti Patnaik ma'am.
दारू देलु
Thank you so much, everyone. Now I would like to invite the Joint Secretary OCS 2024, Dr. Smruti Patnaik ma'am, to offer the vote of thanks. Ma'am, please.
A very good afternoon to one and all present here on this August occasion. I would like to give my heartfelt thanks and gratitude to the luminous personalities of the dais and on the dais present here. ମୁଁ ସମ୍ମାନନୀୟ ସଭାପତି ସାର୍ ଓଡ଼ିଶା କେମିକାଲ ସୋସାଇଟିର ସମ୍ମାନନୀୟ ସେକ୍ରେଟାରୀ ସାର୍ ଆଉ ସମ୍ମାନନୀୟ ନିର୍ବାଚିତ ସଭାପତି ମ୍ୟାଡ଼ାମ ଆଉ ସମ୍ମାନନୀୟ ମୁଖ୍ୟ ଅତିଥି ରେଣୁବାଳା ମ୍ୟାଡ଼ାମ এবং এটি ଯେଉଁମାନେ ସବୁ ଉପସ୍ଥିତ ଅଛନ୍ତି ମୋ ସମ୍ମାନନୀୟ ସାର୍ ମାନେ ଏବଂ ଏକ୍ସ ପ୍ରେସିଡେଣ୍ଟ ମାନେ ସମସ୍ତଙ୍କୁ ଆଉ ଏଠି ଯେଉଁମାନେ ସମସ୍ତେ ଅନ୍ୟମାନେ ପିଲାମାନେ ଯେଉଁ ଡିୟର ଷ୍ଟୁଡେଣ୍ଟ ସବୁ ଉପସ୍ଥିତ ଅଛନ୍ତି ସମସ୍ତଙ୍କୁ ମୋର ହୃଦୟ ଭରା ଶୁଭେଚ୍ଛା ଏବଂ ଅଭିନନ୍ଦନ ଜଣାଉଛି। ମୁଁ ପ୍ରଥମେ ଇନଷ୍ଟିଚ୍ୟୁଟ୍ ଅଫ୍ କେମିଷ୍ଟ୍ରି ଯେଉଁ ଆମର ହେବା ପାଇଁ ତା ପାଇଁ ଗୋଟେ କାଲି ହେଲା ପରେ ଗୋଟେ ମୁଁ ଯେହେତୁ ଟିକେ ଲେଖାଲେଖି କରେ ତେଣୁ ମୁଁ ଗୋଟେ କବିତା ଲେଖିଥିଲି ଯେଉଁଟାକି ପଠେଇ ଦେଇଛି ପ୍ରମେୟରେ ବାହାରିବ ସ୍ୱପ୍ନର ପାରିଜାତ ଯେ ସ୍ୱପ୍ନ ସବୁବେଳେ ସତ୍ୟ ହୁଏ ନାହିଁ କିନ୍ତୁ ଯେତେବେଳେ ସ୍ୱପ୍ନଟି ସତ୍ୟ ହୁଏ ସେତେବେଳେ ମନ ହୃଦୟ ସମୁଦ୍ର ଲଙ୍ଗି ମହାସମୁଦ୍ର ଲଙ୍ଗି ମହାଆକାଶ ଲଙ୍ଗି ମହା ଅନ୍ତରିକ୍ଷରେ ବିଦ୍ୟମାନ ହୁଏ। ତେଣୁ ମୋର କବିତାର ଶୀର୍ଷକ ହେଉଛି ସ୍ୱପ୍ନର ପାରିଜାତ। ସ୍ୱପ୍ନର ପାରିଜାତ ଏବେ ଆମର ପ୍ରସ୍ଫୁଟିତ ଇନଷ୍ଟିଚ୍ୟୁଟ୍ ଅଫ୍ କେମିଷ୍ଟ୍ରି ଆମର ହେବାକୁ ଯାଉଛି ଭୁବନେଶ୍ୱରରେ। ତେଣୁ ମୁଁ ସେଥିପାଇଁ ଗୋଟେ କବିତା ସ୍ୱପ୍ନର ପାରିଜାତ। କିଛି କିଛି ସ୍ୱପ୍ନ ଆଣି ଦିଅନ୍ତି ମନ ଭିତରେ ଅନେକ ଆଶା ଓ ବିଶ୍ୱାସର ସୂକ୍ଷ୍ମ ଭାବନା। ଜୀବନ ଅଚାନକ ରଙ୍ଗୀନ ପ୍ରଜାପତିଟିଏ ପରି ଉଡ଼ି ବୁଲେ ଏ ଫୁଲରୁ ସେ ଫୁଲ ବାସନାୟିତ ଶିହରଣରେ ଶିହରିତ ଦେହ ଓ ମନ ଉଜ୍ଜଳିତ ଆତ୍ମା ବିଭକ୍ତିକରଣ ମୁହୂର୍ତ୍ତ ଶୀତ ସକାଳର ହାଡ଼ଥରା ଶୀତ ହେଉ ଅବା ଭିଜା ଭିଜା ବର୍ଷାର ସାରାଦିନ କଲେଜ ଛକରେ ଚା ଦୋକାନରେ କଲେଜ ପିଲାମାନଙ୍କର ଭିଡ଼ ଦେଖିବାକୁ ସ୍ୱପ୍ନର ପାରିଜାତ ବାମ୍ଫ ଉଠା ଚା କପର ବାସ୍ନାରେ ଭରପୁର ହୋଇ ରହିଥାଏ ସ୍ୱପ୍ନର ଖାମଖିଆଲି ବିନ୍ଦାସପଣ। କେବେ କେବେ ଇଚ୍ଛା ହୁଏ 7 ସମୁଦ୍ର 13 ନଈ ପାରି ହେଇ ପହଞ୍ଚିବାକୁ ସ୍ୱପ୍ନର ମହାଣରେ ପରନ୍ତୁ ଏତେ ସବୁ ସ୍ୱପ୍ନ ପାଇଁ କାହିଁ ଯେ ଉପାଦାନ ଓ ନିଶ୍ଚିନ୍ତ ମୁଦ୍ରାର ବଳର ପାହାନ୍ତି ସ୍ୱପ୍ନ ହୃଦୟରେ ରହିଯାଏ ଦାଗ ହୋଇ ପାହାନ୍ତି ସ୍ୱପ୍ନ ହୃଦୟରେ ରହିଯାଏ ଦାଗ ହୋଇ ହେଉ ପଛେ ଅଳ୍ପାୟୁ ସେ ମିଠା ମିଠା ବାସ୍ନାରେ ପୁଲକିତ ହୋଇ ଉଠେ ସାରା ହୃଦୟ ପାପୁଲିରେ ପାରିଜାତ ଯେମିତି ଝରି ପଡ଼େ ଅଚାନକ ହାତ ମୁଠାରେ ପାପୁଲାଏ ପାରିଜାତ ଯେମିତି ଝରି ପଡ଼େ ଅଚାନକ ହାତ ମୁଠାରେ ମହକାରୀ ତାର ନିଜସ୍ୱ ପଣ ସ୍ୱପ୍ନରେ ଜୀବାହିତ ଜୀବନର ମୌଳିକତା ସ୍ୱପ୍ନରେ ଜୀବାହିତ ଜୀବନର ମୌଳିକତା ପ୍ରସ୍ଫୁଟିତ ସ୍ୱପ୍ନ ସଦାକାଳ ପ୍ରସ୍ଫୁଟିତ ବିସ୍ତାରିତ ବିଭାଜିତ ଚିରକାଳ ଜୀବନ ଜୀବାର ନିଖୁଣ କଳା କୌଶଳ ଆଙ୍ଗିକ ଉପଲବ୍ଧିର ଅବିକଳ ଚିତ୍ର ରୂପାନ୍ତରିତ ଆଜି OUTR କନଫରେନ୍ସ ହଲରେ ଇନଷ୍ଟିଚ୍ୟୁଟ୍ ଅଫ୍ କେମିଷ୍ଟ୍ରି ଆଜି ପ୍ରସ୍ଫୁଟ ହେବାକୁ ଯାଉଛି ଆମର ଏହି ରାଜଧାନୀ ଭୁବନେଶ୍ୱରରେ ସମସ୍ତଙ୍କୁ ଅଭିନନ୍ଦନ ଶୁଭେଚ୍ଛା ଅନେକ ଅନେକ ଶୁଭେଚ୍ଛା ଅଭିନନ୍ଦନ ସମସ୍ତଙ୍କୁ ଆମର ଏହି ସ୍ୱପ୍ନର ଖାମଖିଆଲି ବିନ୍ଦାସପଣ ପାଇଁ ସ୍ୱପ୍ନର ପାରିଜାତ ପାଇଁ। Then I would like to extend my vote of thanks to all the dignitaries present here, luminous dignitaries. My heartfelt special thanks and gratitude to all the luminous dignitaries on the dais and also thanks to the guests of the dais. I am speechless so far the hospitality is concerned. Once again I extend thanks to the valued host for providing all help and cooperation. In fact, the OCS is indebted to the magnanimous institute. I feel proud of myself being a part of this ever-growing body. Thank you. And also, I would like to extend my special thanks to the Secretary of OCS for his hospitality and hard work, not leaving any stone unturned, making it a grand success. And thank you for his positive attitude, aspirations. Thank you for supporting us through thick and thin. And the most colorful, beautiful is our students.
The journey is smoother for 3 days and beautiful for 3 days for the presence of all dear students in this conference hall, in poster presentation, in oral presentations. And I sincerely thank you all for your efforts and hard work during this 3 days conference. I also extend my special thankfulness to the Professor Bingaranjan Das, the convener of this conference, 3 days conference. I truly appreciate the confidence of our President of OCS, Professor GB Behera sir. I value the insights and guidance you provide, sir. And the last but not the least, I extend my warm thankfulness to all the guests present here in this colorful occasion, beautiful occasion, because chemistry is always colorful, always comfortable, always confidential. So therefore, I now request and all of you, and I request Lord Jagannath to be blessed all the dignitaries present here, to all the guests present here. Thank you, Jai Jagannath. Bande Jagannath.
With this valedictory function, the 38th Annual Conference of OCS and National Conference on Advancements of Materials Chemistry has come to an end. I would now like to request all the dignitaries and guests to please proceed for the lunch. Thank you, everyone.
ଫଟୋ ନେଇଯିବା ଶୀଘ୍ର ଡେରି ହେଇଗଲାଣି।